thank you all for joining me. My name is João Martins. I'm a developer advocate here at Autodesk, and I work specifically with the cloud platform that we have. Previously, I guess that in this name of this masterclass, you should be able to see Forge platform. We just did a rebranding, so we are now calling as Forge as the APS, which stands for Autodesk Platform Services. Is a way to ensure that the name covers that this platform is part of the Autodesk platform for the cloud products, all right, for the cloud offering. As I said, I'm a developer advocate. I work with a team of tens of other developer advocates all around the world. As you can see right here, this is just a few of our team members. We are based in Japan, China, India, Kenya, Russia, Europe, US East, which is my time zone, USS West, and we also have people for business related information, all right? So our job here is to help you to better use our platform. And we do that through the support of your questions, support of your developments, helping you to understand how you can use our APIs through trainings such as this one. We also have accelerators and lots of events that you can take advantage of, all right? So I'll be covering with you this masterclass today, and Jaime will be covering, Jaime Rosales, this one right here. We'll be covering the one on Thursday on site, all right? So first of all, we need to talk about APIs, formerly Forge. What is APIs? APIs is a set of RESTful APIs that you can use to build your applications. Our APIs are language agnostic, so you can use them with your preferred stack with no problem. We have most samples using Node or .NET, for instance, but you can be built with any framework that you are most comfortable with. We are talking about mostly web applications. You can build desktop applications also, but mostly we're talking about web applications. So basically, we'll be handling a lot of HTML, CSS, and JavaScript to build our app. And then on server side, you can choose any language available, all right? During this training, I'll focus on the .NET. I'll use .NET framework, but feel free to follow along using .NET later, or if you prefer Node.js. The APIs, the important part is that API, it is the same. It is not dependent on any specific language or framework, all right? If you go to our platform, this address right here, it still has the previous name. It's still being called referred as Forge, but as I said before, we changed the name. Now it's APS. And you can take advantage, if you go to our documentation page, you see all of our APIs that we have available. And this list is growing each day, all right? We have APIs to support management of files. And by files, I mean mostly the models that you produce with one of our applications, our desktop applications. We have APIs to manage translations, manage the generation of data from those specific files, manage conversion between multiple files that you can be interested, and also a full list that's growing to render those designs on the browser and connecting with our cloud products, such as Construction Cloud and Build 360 that you can see here on the bottom, all right? Let's go real quickly to our platform. This is the web page that I was talking to you about. We have a short introduction video on what is a Forge or APS platform, and this is the one I was talking to you about briefly. All right, this is for authentication. Data exchange is a new tool, a new feature that we have on our platform. We're not going to cover that. Today, we are going to cover the core services of APS platform. What I mean by core services. Core services are the services that are used by most of our applications, most of our customers' applications. Basically, what you're going to do, you have your design. In this case, the focus of this training here will be dealing a lot with Revit files. So you have your Revit file, you want to upload it, they make it available in the cloud, and from there, you want to view your designs without the need of Revit itself. So this is what we are going to do. We'll build a simple application to render our designs on the browser and take advantage of the data that was generated when we were designing these files, all right? We'll focus more on this API right here, data management, and also this one, model derivative, and then last but not least, viewer. And to manage the authentication of our application, we will always use the authentication. It's used on the OAuth 2.0 standard, all right? On the second session of this masterclass, of this tutorial, we'll cover mostly design automation, specifically for Revit itself, right? I'm not going in details right now, but you can expect that after we build this first application, this simple web application in this first session, you take advantage of that, of this knowledge to use design automation and to see the great potential of this API, right? Now let's go back to our presentation. Before we jump into the tutorial, let's cover what we can do with our core services. The first API that I want to talk to you about is Data Management API. Data Management API enables you to access and upload files to our servers. Basically, to perform a translation or generate data that can be visualized in the browser, you always need to make your design available in the cloud. And more specifically, for a specific step, you need to make this design available on our server. APS, formerly Forge, uses AWS for infrastructure. So if you are familiar with AWS, just out of curiosity here, anyone familiar with AWS S3? If you are familiar, please use a reaction. You can add a thumbs up. No one? Okay, so I just say APS uses AWS as infrastructure. So in AWS S3, we have two main entities. One is a bucket, and the second one is an object. Basically, you can think of a bucket just like a folder. When you are storing your files locally on your desktop, you have folders and you store your files, your Revit files, your designs inside those folders, right? In the cloud, through APS, we'll be always using buckets to store files, and the objects that are stored in these buckets are our Revit files, all right? To manage the creation and the management of these buckets and files and objects inside the buckets, we are always going to use Data Management API. And we can take advantage of this data in two specific ways. You can build your specific application to create buckets and upload and download files from these buckets, or you can use your APS application, your formerly Forge app, to connect with files inside a specific product, such as Fusion Teams, Paint 360 Docs, ACC Docs, all right? Sorry, this was an accident. Okay, we are going to cover this step right here today, the Forge app-specific storage. We are going to create a bucket, which is the repository for your designs, upload designs to this bucket, and from there, render this design in a web application through the browser, all right? We have one more person, Kartik. All right, just join it. Welcome. All right, to take advantage of this storage, we are going to use a specific authentication, which is called two-legged authentication. Basically, our platform works we need to provide a specific authorization to use any of our services, all right? And to use this service, we need to call the OAuth, the authentication API, and retrieve a token. With this token, we can perform all of the actions. It will be clear as soon as we jump into the tutorial. So far, we need to know that we are going to use data management API to manage our designs and buckets, and we are going to use buckets from AWS to store our files. To help us understand this concept and take advantage of data management API, we have these samples right here. We have the OSS manager. We are going to use that a lot in the second part of this tutorial. We have model derivative sample to take advantage of files stored in ACC or B360. And we also have a really cool extension for Visual Studio Code. Is a plugin that covers most of our services through a plugin for Visual Studio. All right. Is anyone here using ACC or B360? Is anyone familiar with B360 or ACC here? Molly and Joseph. All right. So we are not going to cover the connection with B360 or ACC in this training, but we have a tutorial for that. It's just like the one that we are going to build today. But you need to know that through data management API, you can have access to B360 or ACC, hubs, projects, folders, items, and versions. All of that is managed through, can be managed through data management API, right? Cool. Now let's talk about the other part of our core services, which are model derivative API, viewer itself, and last but not least, we can talk about a little bit about data visualization. First of all, model derivative. Model derivative has been the bones of the APS platform for many years. It is commonly used with viewer itself because we have a common workflow that you have your file on desktop, upload to the cloud, upload it to a bucket using data management, generate a translation through model derivative, and then you can view this translation through using the browser itself with the viewer API. This is the most common workflow, and we'll cover this today. But model derivative can do more than that. Model derivative can be used to extract data from file formats. So we have a Revit file itself with all of its data, geometries, metadata from materials, geometric information, and meshes, and everything there. But you can't simply query specific data. I can connect this data from this design, from this Revit file itself, to a specific, connect it with a specific external database. I can query this to generate an Excel spreadsheet from the cloud itself, from a Revit file. That's when we can use the model derivative itself. Through model derivative, you can extract the hierarchy tree of this element from the model to the categories, to the family types, to the instances. We can take advantage of all the hierarchy of our model. We can take advantage of the properties from each of our specific elements and also its geometry. Model derivative can also be used to convert multiple designs between formats. For Revit files, for instance, we can use model derivatives to convert from RVT to IFC in the cloud without the need of someone going through the Revit itself on desktop, open the file, generate the conversion, right? So this is what is generated from model derivative itself. The way it works is that we need to specify a specific file to be translated, and after this translation, it's going to generate the thumbnails for that file. It's going to generate information on geometry and the specific metadata for that file itself. Before I jump a few more into model derivative itself, I would like to show you which translations can be done. If we go to our documentation inside model derivative itself, no, this is token flags, sorry for that. If you go under model derivative, there is an option here called supported translation. So through this page, we can see every translation that can be done, every conversion that can be done by taking advantage of model derivative itself. So for instance, if you go under the input file of Revit file of a Revit input, we can see that we can generate DWG for a specific view from this Revit file. We can generate an IFC, and we can also generate these three formats right here. These SVF and SVF2 are the formats that are used by the viewer to render a specific design, a specific model, right? So when you see, for those of you that know ACC or P360, when you select a specific model and it renders the design in the browser, it's actually rendered this translation right here, this SVF or SVF2. So basically, we have the input, the translation, and the result for translation can be rendered using viewer itself. All right. Let's go back to our, if you have any question, please just ask, all right? I can always stop and address your questions properly. All right. Talking about model derivative a bit more, as soon as we translate, we submit a specific translation, it's going to generate for us a file called manifest. And through this manifest, we can keep track of the status of our translation. It can take more or less time depending on the complexity of our design. If it is a large design with multiple geometries, multiple meshes, multiple information, it might take a considerable amount of time, all right? And from there, once the translation is done, we can take advantage of the hierarchy and the metadata, just like those thumbnails right here. We can also use Always Count on Postman and Insomnia to take advantage of all the APIs of the APIs platform. We are going to use Insomnia today. So by the end of this masterclass, I hope you to be quite familiar with Insomnia. All right. And before we conclude this introduction, let me just share with you a few samples. I haven't spoke about viewer and data visualization itself. Right here on the documentations, if we go under viewer, we can see more information about viewer itself. What is viewer? Viewer is a library on the browser that is going to be used on our application that we're going to build. And it's based on the open source project called 3JS. Let me go right here. It's based on this project right here, 3JS. So we have a specific revision of 3JS right now. Is on the revision 146. We have a specific revision going on the viewer itself, viewer library, with a few modifications, with actually a lot of modifications. So basically, if you have any extension, any sample built for 3JS, it should be easy to migrate it to work with also with viewer, all right? And instead of just going through the documentation of viewer, let me go through a few samples with you. First of all, we can see this basic app right here. This is viewerrocks.autodesk.io. It's just to show the concept of viewer itself. Right here, you can see a model. It's loading on the browser with a response time quite good, actually. And you can take advantage of a few tools that we have available by default when we use the viewer library. We can perform a task to rotate this design automatically. We can also explode this design as we need. We can also take advantage of, let me use this. We can also control this explosion itself. And we can also query metadata of each specific part of our model. So what happened here? We had this model, I guess this is from Inventor itself. We uploaded it to a bucket, generated a translation, and from there we can take advantage of all of these geometric information, the geometries, the meshes, and the metadata for each of these parts. The same for a Revit file itself, right? Let's move to a sample that's most interesting for us. Let me see what I can share with you right here. If we go under Forge Tutorials, Forge Showroom. If you go under forge.showroom.autodesk.io, you'll be able to see multiple examples. These are proof of concepts built by our developer advocate teams. And we build this to show what can be done using our APIs itself. All right. And we have one really cool, that is this one right here. This is the first one that I would like to share with you. It shows a really cool concept. Here we have connected one viewer for our 3D design and one viewer, a second viewer for our 2D view of this same model. When we talk about Revit models are actually a three-dimensional representation of an existing building, of a complete design, all right? So when we talk about a 2D view, these are not only lines. These are representation in a bidimensional view of this whole element itself, in a way that I can select a specific element from this view right here. Let me take this wall, for instance. If I select this wall on the 2D view, I can select the same wall on the 3D view, because this is the same element that's being represented, all right? If I check the properties right here, I can see all of the metadata that were generated by this element itself. I can take advantage of its dimensions, its identity data, the phasing, construction graphics, and everything that can be available, all right? Viewer comes by default with all of these extensions that you can see on the bottom of this page of this viewer, of this scene right here. We have a specific extension, a specific tool for measuring, for taking measurements on our model. And we have full control over the precision and the units, measurement units. We can make cuts on our model to analyze it in a better way. Can do like this, for instance. We also have a really cool one, which is the option to have a walkthrough on our model with a first-person view, all right? And this is the same model that were designed on the Revit itself. Once more, to be clear, this is not the Revit file itself. We had the Revit file, we generated a translation using model derivative generated the SVF, and then we can render this SVF generated inside the browser using viewer library, all right? Is that clear? Hope it is. We'll see this a lot in this tutorial, so it will be clear if it's not. Really cool. We can see all of the textures and so on. And right here, as this is a web application, we have full control of what we and how we are going to present everything on this web application. And by everything, I mean that we can, for instance, add a dashboard on this tutorial, on this app, and this dashboard can be connected with our elements from our design itself. in a way that I can specify in this bar chart to show all of the system types and here all of the categories. So let's say if I click on the category Revit pipe fittings, I'm going to isolate all of the pipe fittings. I can also, let me show all objects. I can also isolate by domestic cold water elements. So now I see only domestic cold water elements from this specific system type. Then I can change for any property that I have available in my model itself, right? This sample is really cool. If you have any question, just let me know. Another one that I would like to share with you is the beam phasing. Let me load it here. Frequently, we have customers interested in building construction phasing, integrating construction phasing with our designs in a web application using APS itself. So that's what's being done in this application, in this proof of concept. We have basically the Revit design itself, and we can keep track, we can use specific viewer methods to isolate and control the visualization depending on the element phase that we have right now. For instance, let's select this floor right here. It has a specific phase created, and it's called phase 1 site. If I select this roof right here, I can see it was created in phase 6. If we filter all of these elements based on this phase created, we can have a construction phasing of our whole model itself. And from there, we can build integration. We can build an app to show us how the construction is going to be executed. And this is what is done through this, what can be done through these extensions right here. Let me see if we have a specific error message right here. No error message. Let me just refresh it. Okay. Okay, now it is good. So first of all, we will have only the floors being built. On the second phase of our construction, we'll have the foundations of our main building right here. And on the third phase, we'll have the steel structural elements. So from now, I can walk in the first person view as it gets more interesting. And I can keep jumping to different phases. Now I can see the concrete. Stairs are being built on the second phase, and then roof, exterior walls, curtain walls and windows, parking, partitions, ceilings, air conditioning systems, plumbing, and electrical. All right? At the end, we'll have all of the models. Everything that you can see right here is done by taking advantage of specific viewer methods. For viewer, we can control which elements are going to be seen or not. This is quite simple. And we can also override the color of our elements. This is what we're doing right here. The sample is override the color of the element that is built, that is present on this specific phase that we are, and it's turning its color as green, right? Really cool extension, right? I'm going to share now this link with you. If you have any questions regarding any of the samples that are shown here, you can please let me know. We're not going to cover the samples today, but it's always a good start to get to know better our whole platform itself. And I haven't spoke about data visualization. Data visualization is our addition to APS platform in a way to address the common workflow when you want to create a digital twin. Data visualization, let me go over the API documentation right here. Data visualization is a set of tools that is already available in Viewer Library itself to help you visualize information from sensors and connect this information from sensors with your design itself. It consists of a full tutorial, a full web application, reference application that you can go through in this tutorial right here. And it's going to give you, first of all, a model with mock-up data to see how it works in the model, this connection in this visualization. And from there, you'll be able to add your own model. And last but not least, you'll be able to bring your own data from your own sensors. If you like, there is a Hyperion. There is a Hyperion sample right here under this address that you can simply go and take advantage of. Right here, this is just like the sample application that we provide on the documentation itself. It's going to show us the main functionalities of the data visualization, extension with a model provided by us, right? We have functionality to select one specific floor that we have interested in this floor. We have information about the sensor itself. The sensors are positioned in the scene, the three-dimensional scene, according to the position of the sensors in the real life, the real position of the sensors. And we can connect this data with the room where the sensor is positioned. So we grab the data from the sensor and represent right here, based on these thresholds, how this building is performing. In this case, we have a specific temperature on this time that can be updated on a real-time basis. All right. So if you are interested in building a digital twin to integrate with sensors, Hyperion is the first step for that. Last but not least, we have a really cool, brand new sample connecting with external database, and it shows a few more concepts. This is already addressed as Autodesk Platform Services, and this is somehow like the app that we are going to build today. In this case right here, we are interested in connecting with external database. Let's say you have your whole design, your whole model, and the information of the model, and you want to connect with an external database for cost estimation, for instance. So each of these elements will have information in an external database that is updated regularly. The model don't need to be updated. Let's say we just finished this model, but the pricing needs to be updated. So we can update it in an external database and connect with this model. The sample is doing that in a way that as soon as you select an element, it will take advantage of one event that we have available for viewer. It's going to grab the information on the external database for this specific model, for this specific element, and then as soon as it receives this information back, it's going to populate this information inside our property panel. This is going to show that we have full control on the customization of the property panel from the viewer itself. In this case, we are adding external information, and we are also doing that in a way that we can modify this information from here and update it in the external database. All right. So focus on this. This wall price, I change it to 990. So let me reload this model. This wall, I'm retrieving the data from database, and the price is 990. So it updated the external database from the viewer itself. All right. So basically, any workflow can be covered using our platform. All right. Cool. So right now we can jump into our tutorial. Before we jump to our tutorial, do we have any question? Now's the time. Okay, how to convert these samples to link our own ACC models. Okay, let me go back. We have, this is the page for our tutorials. We are actually going to forge.tutorials. Karthik, I hope I'm saying your name properly. If I'm not, please correct me.
No, you got it right.
Oh, all right. How to convert the samples to link to our own ACC model. So basically you have your ACC hub with multiple models and you want to view outside of ACC with a sample application, right? Is that right?
Yeah, correct. Yeah.
All right. Sorry for that.
I actually tried to build these 3 apps with these instructions. It was really helpful. But the thing is, the samples are unique in its own way. So how do you convert them? Like, what are the steps you need to change to make it work with your own Forge app, if it makes sense? Like basically recreating the app to your internal Win 360.
All right. The way it works is that to connect with a specific ACC or Win360 account, you need to go through this step right here. Provisioning access in other products. So we are going to cover this in the first phase of the tutorial. You need to create your APS app, and then you receive the credentials, right? Credentials, the client ID and client secret. Then you need to provision your credentials from your app inside the specific hub that you want to connect. From there, your app can have access to the data from this hub. You can have access to the hubs, to the hub itself, to the projects, and inside the projects you have the folders, the items, and the versions itself. Once you log in with your in this specific application, this sample application right here, it will generate what we call the three-legged authentication, the three-legged token. Three-legged token takes advantage of the permission from your APS application, of your user that logged in, your Autodesk account, and then connect with a Forge server. From there, you will be able to access data that your Autodesk user has access. For instance, as soon as you give a provision to a specific hub, the app can see all of the hub projects. Let's say the hub had 10 projects, but you, as a user, only have access to one project, one of these 10 projects. When you log in this application and generate the three-legged authentication, the three-legged token, the app will only be able to see the one hub that you have access to. All right. Is it clear, Karthik?
Yeah, makes sense. Also, I noticed when I was testing this, some of the hubs don't appear. Is there a kind of like a permission that minimum permission required for hubs to appear in this? Like sometimes I get invited to external projects, but I don't see those projects. Is there a minimum requirement for hub to appear in a Forge app?
Yeah, for the hub to appear, you need to be provisioned. Each hub needs to be provisioned individually. All right.
Okay, gotcha. Okay.
So,
Understood.
and also, if you don't have access, if your Forge app has access, but you as a Autodesk user don't have access, using the three-legged authentication, you won't be able to access it, right?
Okay, gotcha. Yeah.
All right. Now let's go back to the presentation. Any more question? Any other question? No? If not, Then let me share. Okay, where is the link to present it? Okay, now let's build our basic application, our basic app. We still have time. Okay. This sample application that we're going to build is called Simple Viewer. It's on the tutorial that I was sharing with you before, and it can be. We have two tutorials, one for .NET and one for Node. I'll be using the one for .NET, also because we need to use .NET Framework 4.8 to use to build our plugins for design automation and to build our app bundles to design automation and Revit API itself. So, and also I use .NET a lot. So we need to choose one. I have chosen .NET, but feel free to grab any of your preferred framework languages, or even go through the same tutorial in Node.js. It is the same. The client-side content is the same. The only changes are the ones in the server side itself. So this is the goal for this session. We are going to build a basic application that is going to help you understand the basics of our platform. I know that I said before about data management itself, but it's always good to repeat a little bit so we have the concepts clear. And it's really useful if you guys take advantage of this time. Ask questions. If you have any doubts, maybe it's something that you think, oh, this is because I'm seeing for the first time. No, if you have any question, anything on your mind, just share and we can go through it together. And hopefully you won't have this doubt for a long time, all right? So first of all, the step one, just like all of our samples, it is required we need to build the server side, to build the specific server for our application. But before we do that, we need to take care of our APS account, the formerly forged account, and retrieve the credentials that we are going to need. After that, we need a developer environment. As I'm doing .NET, I'm going to be using Visual Studio Community version 2022. But if you go with Node.js, probably you are familiar with Visual Studio Code. We also have the extension for Visual Studio Code, so feel free to do that. If you go with this .NET, just like me, you don't have it already, please download Visual Studio Community version 2022 and make sure that you have the ASP.NET and web development workload, and also the .NET desktop development. This is going to be useful when we build the plugin on the session 2 of this tutorial. Now let's cover the first part. First of all, the Revit account, the APS account. So I'm on Google Chrome right here. Okay. I'm going to create a Forge account, APS account for this tutorial. So let's go under APS. We can select sign in. Let me use this one. Let me call AECtech. What I'm doing right here is I'm going to use this email and just additional alias just for this tutorial. So it's going to be called like that. But I don't have this account created as an Autodesk account. The first step to have an APS account is that you need an Autodesk account. So if you don't have one, you need to go through here. Let me call my name. This is the email. And password, and agree with the terms. Let me not save it. And now I receive it in my email, a link to verify my account. I'm just verifying my account here. Okay, my account is verified. Now I can log in. Let me try this more. Let me try this more. Okay, now I should be able to do it. Okay, as soon as I log in with my new account, as you could see, I just created this one. If you don't have one, will be just like what I just did. You go through the trial. In the trial, you have 90 days with enough credits to take advantage of all of our APIs, all of our services. Some services consume credits and others don't. You can understand it better if you go under pricing, but for now, you only need to know that as soon as we upload and translate a specific Revit design, it's going to generate a consumption. But don't worry for that now, because you have not enough credits to try anything. Try design automation and also model derivative itself. So first thing we need is a APS application. So we can go over here under APS, under applications. And as we don't have any, we need to select create application. Let me call this application AECtech, right? As soon as you create this application, we will receive the client ID and the client secret. These two client ID and secret are going to be exchanged by the token every time that we need to use a specific service. So we provide the client ID and secret. Our server is going to check if this app has access to what we need. And from there, it's going to grant access and consume credits under this account right here, all right? Every app that I create is going to consume credits from this account, okay? Here we have the callback. We are not going to use for this first tutorial. For the second session, we are going to use, and we will add a new one. You can provide a description, and you can also specify which APIs your app will have access to. If I don't select any of these, our app will won't have permission to perform any task. Today, we are going to use mostly data management API, design automation, and model derivative itself. But just for simplicity, I'll leave everything selected so you can do the same. As this is just a trial account for testing, let's say tomorrow you want to try a different API. So you don't have to create another app or go through here once more and enable additional services. So let's just save everything, and okay, we have our APS account and app created. Second, we also need Visual Studio Community. If you don't have it already, you can download it from here. Let me share with you the links that I'm using. You can download it right here. It should be in English. Sorry for that, but you'll be able to see it in English. And when you download, please ensure that you have the workloads, the proper workloads, and you can check those as soon as you open Visual Studio Community. Let me open my parallels. So far, so good. Okay, right here. This is the icon for Visual Studio Community. Okay, now it is opening. Oh, great, I opened twice. Let's continue without code. And if we go under Tools, Get Tools and Features, in the installer, let's just wait for it to load. Everything that I'm doing is covered in the Getting Started section of our tutorial. Create an account, creating the app credentials, and then the environment setup. I'll be covering this one right here, .NET 6 and Visual Studio 2022. These are the workloads that we're going to need. ASP.NET Web Development for our web application, and .NET Desktop Development for design automation and the app bundle, to build the app bundle for design automation itself. It is taking a lot of time here, so just count on these steps covered right here on our tutorial. And from there, we should be able to begin building our application. All right. Just for me to get to know, is anyone here that needs to download the Visual Studio? Are you planning to build this right with me right now, or just follow the instructions to build it later? Do you have Visual Studio already? It's easier to answer, right? You can use the chat window. Oh, for later. All right. All right. So I'll go faster. Also for due to our time that we have available, but we have a recording going through each of these steps with all of the information, all of the time you can pause and keep going on. So I can share the link with you later also. Right now, let's go to the step 2. In the step 2, we are going to start building our application, the server side, more specifically. Before that, it's always good to get to know better the architecture of our application. We can separate our application in 3 layers, as you can see in this diagram right here. We have the Forge, the EPS servers, where your data is stored, and you can access our platform services for uploading the files to buckets, for translating the files, and so on, and any other APIs. And to access the services and the data, the information on our server is controlled through OAuth 2.0. And this is where we have a token-based authentication and authorization. Basically, you have your credentials, app client ID and secret, you exchange that for a token, and using this token, you can perform any supported task. You can use any supported services using under your specific account. We'll build the client side, the front end, and the server side from our application. and using the user interface to our application, we are going to connect with the All4 APIs. For instance, if you want to upload a specific design to the bucket, you have an interface button, a button in the user interface to upload this file. And from there, we are going to trigger a translation. And from there, we are going to consume this data to render using the viewer itself. The server side of our application is going to provide the static files. The static files will be the HTML, JavaScript, and CSS files. They are going to be passed to client side. And the client side is where the user interacts with our application. Except for rendering the translated model with viewer, we'll always use the server side to make the calls to Forge server itself. So just like I said before, every task will be performed every call to Forge server will be made from the server side itself, except with only one exception, which is downloading the SVF, the format of our design to render in the client side, render in the browser. First things that we need to address is the setup of our application. We need to prepare the startup.cs, the configuration, and also add the secrets from our APS application, the client ID and the client secret. We also need to create the basic server. And after that, we are also going to cover right now the authentication. Authentication, again, is the base to use any of the APS service. Let's do it right now. Let me close this one. This was just to show your concept. Okay, and let me open this on Windows. It will be easier. No, I can keep it right here. All right, first of all, application setup. And I'm going to cover this step right here using .NET and Visual Studio Community version 2022. So first of all, I need to open Visual Studio and create a new project. So let me open and select create a new project. After that, we need a specific template for this application. We need to select the ASP.NET Core Empty. If you select the wrong one, you have additional content and additional configuration that might give you some headaches, all right? So just go with ASP.NET Core Empty and select Next. Here, we need to specify the name for our project. Let me call it AECtech Simple Viewer. We need to specify a location for this project and solution. And just for simplicity, I'm also going to place the solution and the project in the same directory. Now select Next. Now is the part where we select the framework. .NET has always both .NET and Node.js, they have long-term support frameworks. Those are the versions that are going to be supported for a long period. And the current one for .NET is the .NET 6. So this is the one we're going to use. So I'll ask you to unselect this option, configure for HTTPS, and also select this one, do not use tops level statement. This is really good. Let me see if this is covered. All right, this is not here because it was a previous version of .NET. Let's go with create. And it's going to create our application for us. Okay. As soon as you create our basic application, it should come with this content by default. Dependencies, properties, app settings.json with the app settings.development and the program.cs. All right, first thing that we need to do as soon as our project is done, is created, we need to add 3 folders on the project level itself. First of all, the controllers folder, we can copy this from the tutorial, and inside on top of our project name, we can right click and select add new folder, and in here we can paste the name that we got from the tutorial. We are also going to need the models folder. Same thing, we go under our project name, right click, select add new folder, select models, and also we have a wroot folder, www root folder. Right click our project name, select add new folder, and paste the name. How are we using those? We basically have the controllers that are the entry point from the client side to the server side. So as soon as you select a button, select a specific option from UI, the client side will reach the server side through the controllers. From there, it's going to use the logic of our application to connect with the Forge server. This is done inside our models files. In the wroot folder, we'll store all of the static files that we have, the JavaScript files, HTML, and the CSS. Now that this is covered, we need to add our dependencies for this project itself. That can be done through the dependencies option inside our project. We can also right click in the project name and select manage NuGet packages. Now we are going to add a package that is used for most of our samples, and it's maintained by us. It's the Autodesk Forge package, all right? Always ensure to use the latest stable version. In this case, is 1.9.7. It has most recent features, and if you try to follow this tutorial with your previous version, it won't work properly. So select the 1.9.0 and click on install. Now we need to accept its dependencies, and as soon as it's done, we should be able to see our new package that we added right here under packages, Autodesk.Forge. Okay, now we need to configure our application. We need to create the startup.cs file. This startup.cs file is the entry point of our project itself. It will contain the configuration on where are our static files, how we are going to connect the client side and the server side, how is going to be the routing, and also we are going to, through here, we are going to read the environment variables, specifically the APS application credentials, the Forge Client ID, Forge Client Secret, and Forge Bucket. So let's create the startup.cs. We can, don't do this anymore. We can right click our project name, select add new item. Startup.cs is a class, so nothing to do here. We just add it. And now we need to do something that we'll be doing in most part of our tutorial. Delete the content that comes by default and add the content from our tutorial. Right here, what's doing is configuring basically our server side, adding our credentials. Through these credentials, once more, we are going to connect with the APS services. And there's a verification right here to check if we have both client ID and client secret. Without any of those, we can't generate a token and we can't properly do any task, mostly. We are also mapping the controllers, add user routing, and adding the static files and default files under www root. Right now, we don't have anything, but throughout this session, we'll populate that. Now, we need to add our credentials, client ID and secret, and that is done inside the app settings.development.json file. So we can go right here under app settings.json, app settings.development.json, delete the content that comes by default, and add the content from tutorial. Here, we need to replace the client ID, client secret. This is available on our app that we created. So first of all, client ID. Oh, I missed it. Okay, now it's good. Client secret also. And also a bucket name. Now I have three considerations. As you can see, the client secret is not, to show the client secret, we have a security measure right here through this button. Without this, you are not able to see the client secret. Why is that? Because anyone with the client secret and client ID is able to generate a token with any of the supported permission. If, for instance, now you have access to my client ID secret, so you could, if you had the intention, you could write that down, generate a token, and then, for instance, delete all my files, or generate multiple translations under my specific account. And then I'm going to lose all my credits that were used actually by other person. All right, so this always should keep secret. This is really important to be only accessible by the specific owner of the account. That's why we have these secrets as environment variables inside our server side. Our client side, our end users that are going to be using our app won't have access to any of this information, all right? And if it accidentally gets exposed, we can always click here to regenerate only the client secret. So if I click here, the previous one will have no permission to generate a token, all right? So as I generated a new one, let me just replace it. And now it is valid, all right? We also need to specify for this specific application a bucket name. The bucket, once more, is just like a folder. The bucket is an entity from AWS S3. This is where we're going to store all of our designs, all right? And this name must be globally unique from all the platform itself. Let's leave it as blank because this app has a specific way to ensure that your bucket name is unique. It's going to prefix your bucket name with your APS or formerly Forge client ID. This client ID is unique. So if I use for this bucket name client ID dash sample viewer, it means that my bucket is globally unique because this prefix is globally unique. So if you try to use, to summarize, if I try to use test bucket right here, for instance, it's not going to work because probably this bucket name was already taken, all right? So going back to the tutorial, let me see if you have any question. Oh, downloading it now. Okay, Molly. And okay, now we also need to change the content from the program.cs. So let's go over there. Once more, we remove the content from tutorial that comes, remove the content that comes by default and paste the content from our tutorial. This is basically building your create host builder, this function right here, and using the startup class to configure our server. And last but not least, we need to specify which port our application is going to use. In this case, our sample application always use the port 8080. So we need to change that inside the launch settings, inside the properties folder. So let's go on the properties folder, launch settings, and I'm just going to change the port right here. It always comes with a random port that's not being used. This Visual Studio does that. So we just need to change it. And now we can try it out. If we try it out right now, we have actually nothing to show because we don't have the client side, we have the controllers, we can't do anything. But we can check, what we can do right now is check if we are receiving the proper environment variables, client ID, secret, and the bucket key. So let's add a breakpoint right here and start debugging our application. Once more, the startup is the entry point of our server. So it's going to run this before make it available. Right now it's reading the client ID. And as you can see, we have in this client ID environment variable, the client ID that we retrieved from the environment variables. Same for client secret, and also same for forage bucket. Again, forage bucket, we left it blank. Now it's doing a verification to check if either client ID or client secret are null. As they are not, we are not going to throw an exception, and we are just going to make the application available. But right now, we are going to receive a 404 error because we don't have anything to show. We have nothing to show to our client side. We don't have any content. So this is good. This is expected because we don't have any page to show. We have nothing on our app. That's what we are going to do in the next steps. For now, we can finish the session and go to the second one. All right. So far, so good. Any question? Oh, good. Do you have any question about the authentication methods of our platform? Everybody understood should have access to our buckets and files and so on. We are going to take advantage of the credentials. The credentials generate the token, and with the token, we can perform the activities. We can perform. We can create buckets. We can upload files, and so on. All right. I think I missed one step. Oh yeah. Now we need to take advantage of the authentication. Now we need to cover the authentication on our platform, right? Let's do it right now. If we go to the next step of our tutorial, we have the authentication covered, right? Here we have the steps to generate the token from the client ID and client secret itself. Let's review the architecture of our sample. We have always the client side. From the client side, the user will click a button, will select perform an action, and then the client side is going to reach the server side. The server side from the controller is going to call a method inside the models from inside the Forge server under the model folder, And this method is going to connect with the Forge or APS, formerly Forge, platform itself. So first step, we need to add this logic inside this file right here, forgeservice.cs. From this file, we are going to connect with the Forge server. So let's go inside our models folder. We can right click it, select add new item. This is a class, so we can use this template, and we need to paste the content, the name from our tutorial. Now we get rid of the default content. Just do this. And we can copy and paste the content from our tutorial. In this example, in this sample that we are going to build, that we are building right now, we are going to use partial classes. What we mean by partial classes? Partial classes means that we'll always be adding content to the same class, this Forge service class, but in multiple files. For instance, this file will only have the constructor of this class to store the client ID, secret, and bucket key, and those can be used inside the content of this class itself, as it's private read only, right? From there, we are going to create an additional file, and this additional file will be leveraging the same class that we had before, but this time focusing on the authentication. That's why we have Forge service.auth.cs. And that's why we have this partial class right here. It means that we will have multiple files referring to the same class. This one, we also add this file inside the models folder. So we can right click the models folder, select add new item. This is a class. So we replace the name from the tutorial, get rid of the default content, copy and paste the content from our tutorial. All right, what we have right here? We have two tokens. As you can see, we are addressing an internal token and a public token. We have a function to obtain a specific token, and this function is obtaining the token based on the client ID, client secret, as I said before, and it's always also using what we call scopes. What are those scopes? The token that we retrieve right here has the permission to perform a specific task based on the scope that we specify for it. For instance, let's say that we want to a token only to visualize a model in the browser. We don't need to generate a token with the power to delete our files, the power to upload files, the power to consume our credits, just for that specific task to view files. That's why we have scopes. Scopes are going to limit the token to the steps, to the tasks that they really need to address, all right? That they really need to perform. And that's why we have two specific tokens getting acquired right here. The internal one and the public one. Remember when I said before that all of the calls were made from the model, from the server side itself? The client side, where we have a button, we're going to reach the controllers on the server side, and the server side connect with the APS server. We have only one exception. The exception is when we want to download a file, an SPF, a translation, to render the design in the browser. That call is done right from the client side itself. It's a connection from client side to APS server without passing through the controller. For that, we have the public token. The public token is going to be accessible by the client side. And that's why we only have this scope inside the public token. because with this token, the user can only view your designs to render in the browser, only what it really needs to do. The internal token that can create buckets, that can read buckets, that can write data, that can create content and consume credits, it's going to be only available inside the server side. It's not going to be exposed, and this is really important for the security of your account. Clear? Hope it clear. This part is clear. So right now we have this class, but we don't have this referenced in the sample itself. So right here, we need to update our startup class. We are going to update the startup class in a way that we add this class, this forge service class, as a single tone. Let's go under the startup class, and right here, below the condition test, we are going to add our single tone. Why we're adding this to our services as a single tone? A single tone means that this class will be a static class. It will be one single instance inside the whole project itself. It means that when we generate a token, this is good because once we generate a token and it's stored right here, it's going to be the same token used in the whole server side, in our whole application, a whole instance itself. All right, we are not going to make a call, generate a token, make another call, generate a token. We are going to use a token and use the same one for all of our activities. And if it's not valid anymore, we are going to generate a new one. All right, this is what this verification is doing right here. Oh, this is another good point that I missed. As soon as we generate a token with the scopes that we specify, it's only going to be valid for 1 hour. So we generate a token, we can perform actions with this token for 1 hour. After that, we need to generate a new one. That's why we have this verification right here and this one right here, right? Okay. And now we also need our controller. The controller, once more, is the entry point from the client side to access the server side. So first of all, we need to create our authentication controller, and this is going to stay inside our controllers folder. So we can right-click controllers, select add, new controller. We can use API controller empty. We paste the name from the tutorial, select add, and the same thing that we keep doing. Delete the content from tutorial and add delete the content that comes by default, and add the content from tutorial. As you can see, every time in the controller that we have a function that is accessible by the client side, it's going to have this HTTP GET or HTTP POST. Is usually HTTP with the verb that is going to use. In this case, we have a function to get the token itself. So the client side can reach this function right here to retrieve the token. This function inside the server side is going to take advantage of the forge service single tone, this class that we specified for service, and call this method right here, get public token. So from there, it's going to call this function here that's going to obtain the token only with the scope to view the file and return it to the caller. So right here, we have the token, and they're going to return this token to our client side. And from there, the client side can use this token to download the model and render it in the browser. All right, we have the picture clear here. So now that we have everything covered, let's test it out. we can start debugging our application. All right, now we have the verification, client ID, client secret, forge bucket, all good. Singleton, we added the class. And let me add a breakpoint, a few breakpoints actually. One right here, so we can see as soon as we reach this function from a call from the client side, as soon as we make the connection from client side to server side. And also right here when we select the public token. Let's push play. Let's debug it. And once more, we don't have yet the main page of our application. We don't have contents to show to the client side by default, but we can mimic the behavior of our application when it wants to obtain a public token. This public token right here, it has a specific routing to be reached. This controller, this method right here, it has a specific routing. And the route is API slash auth from authentication and slash token. So using API slash auth from this controller, we can reach this class right here. And from there, if we add slash token, we can reach this specific function right here. So let's go there on the address and call this API slash auth slash token. And now we reached our endpoint from the server side. Every time we have this function accessible by the client side, we call this an endpoint from the server, all right? It's going to call this function from the model itself. Let's go over there. And inside here, we'll take advantage of first of all, it's going to verify if we have the token. In this case, we don't have because this is the first time we're retrieving. Or if we had it, it's going to check if the token is still valid. If not, any of this case, we are going to generate a new token. That's what's going to happen right now. So in this case, the token is null. We don't have it. So we're going to reach this get token function with the scope viewable limited. And from there, we are going to call this method right here. This method is using our library, our SDK that we downloaded using NuGet package, NuGet manager. And with this method, we can obtain the token. Oh, I did something wrong. Okay, we got an error. Let me check once more. It's saying that our client ID does not have access to the API product. Let's try once more. Okay. Client ID, client secret, they are the same ones that we have here before, O2 before, and RG, VZ, RG. Oh, there's a B right here, missing. You see? This one ends with Z, and this one ends with B. So it's missing a B. I copied it wrong. That's the good part about debugging, right? So we can go under the app settings.development.json and add the proper client ID. In this case, we just need to add another B. Usually when you receive this error is because either we don't have the proper API selected right here, or any of the credentials is wrong. So we can test it once more. I'll take this opportunity to drink more water. Okay, now it is good. Let's continue debugging. And now we don't have anything, we have nothing to show. So let's force it to go through our endpoint. So we type API of token, press enter, and now we are back here. We need to verify if the token is null or expired. In this case, it is null. So we need to generate a new one. And inside the getToken function with the limited scopes, we are going to use our library method to generate the token. And this is the response that we receive when we obtain a new token. We have the access token and also the expiration time inside this expires in parameter, right? So we're going to store all of that, return it to the method caller in the controller itself, and then the controller is going to return the token, not the credentials. It's going to return the token to the client side, and the client side is going to show on the browser. All right. Here we have the expires in. It is always in seconds, so 3,600 seconds, so 1 hour. And this is the access token that we can use, that we need to use to make requests to APS platform. If we try to obtain it once more, it's going to do this verification. And in this verification, we can see that the token is still valid because it's valid for 1 hour. We got it from in the past minutes, so it has still 59 minutes at least to work. So we are not going to generate a new token. This is good for timing and for resources, since we are not actually calling the get token endpoint as soon as we need to perform a test. So we're only going to return the token that our application already has, right? And that's it for this session 2. Any question on the token? You are too quiet. All good? Just use any reaction, please. All good, team? Everyone good? Okay. Thank you very much. Okay, now next part is, now we are good for step 3. In this step, okay, I'm having a little bit of delay here. In this step, we'll cover the upload and translation of our designs. Once more, to take advantage of the designs in the browser, we need to upload them to the buckets managed by the APS application, and then generate translations. The translations are going to take the model, in this case the Rabbit model itself, and generate the SVF, the format that is understood by the viewer library itself. We are going to add the logic for listing and uploading files using OSS. OSS stands for Object Storage Service. It's a service from APS to manage these resources. We have the logic for translating the designs using Model Derivative API, and we also need to add the server endpoints. Through the endpoints, client-side is going to reach this logic and connect with the server. Let's go. This is covered in the next step right here, data and derivatives. So first of all, we need to increment the force service class that we are working with through this whole tutorial. Let's add this file, forceservice.oss.cs, inside the models folder. And as soon as we do that, right click, add new item. This is a class. So we go paste the name. It's going to understand there is a partial. All of these files are partials from the same class, are related to the same class. So what we've been doing so far, delete the content that comes by default, copy and paste the content from our tutorial. Let's see what we have here. We have this function, ensure the bucket exists. This is going to, as the name suggests, is going to certify that we have a bucket available to store our files, our designs for translation. It's going to return the internal token. As you can see, for all of the tasks that are server-side tasks, we'll always be using the internal token. This is the token that has the permission to create buckets, to read buckets, to upload files, and trigger translations. This is the bucket that has the power to consume credits on your and resources on your account. That's why it is secured in the server side only. We have this function get bucket details. We are basically trying to obtain details of a bucket from the name that we specified. Where is the name? If you remember properly, we specified a name right here for this bucket. So first thing that we need to do, we need to check if this bucket exists, right? So let's say you call it bucket AECtech. So we need to check, oh, this bucket exists. If it exists, I can upload files there. If it doesn't exist, this method is going to raise an error. So it's going to fall under here. And this line right here is going to create the bucket for us, all right? And to create this bucket is going to use this bucket key that we have right here, right? This function is called in two ways, in two occasions. When we upload a model and when we are need to retrieve the objects from the bucket. As soon as you load this application, it's going to have a drop down with all the buckets that we can use, all of the files, all of the designs that we can use to render in the viewer itself. So that's done through this method right here. This is basically retrieving all of the files available, and this is basically to upload a new design into this bucket. That for both cases, we always need to ensure that the bucket exists, right? To upload a bucket, we have this upload resources method right here. And basically to retrieve the content, we have this call right here, get objects async from our API, all right? And if you pay close attention to this method, we have a while right here. And this while is because our API, our responses are paginated. What I want to mean by that? Let's say each of the responses that our server make to your requests, they are going to have a limited amount of content. That's to handle better the resources that you have. Let's say you have 1,000 elements in a bucket, 1,000 objects, 1,000 Revit files in a bucket. And that can happen, all right? With time, it can happen. So you will not be able to receive the information about 1,000 Revit files in just a single call. So to address that, we have this response next field. We have the paginated result, which in this case, it's limited to 200 Revit files, 200 elements itself. So if you have 1,000, you need to call it one time, receive the first 200, add it to the response items, and then call the second time. In the second time, you receive from 201 until 400. And then we call the third time. Third time, you receive it from 401 until 600. And then you keep calling until you don't receive this next field. If you don't receive this next field, it means that you reached the final page. You don't have more content to receive. So from there, you can just show all of the results to the client side. Great. Okay, now that we have the logic to connect with the server side, we need the logic for managing the designs. We need the logic to translate our designs, right? That is done through this derivative service or service.deriv.cs. So right here, once more, inside models, we can right click, select add new item, is a class. So we paste the name from the tutorial itself. And now we delete the content that comes by default, copy and paste the content from tutorial. We have basically here a function to translate our models to the SVF format. It is specified right here, and the SVF format is the format that viewer understand when viewer is rendering a specific design. The SVF itself, it generates the multiple files in JSON format containing the metadata and the geometries and textures. So viewer can put everything together and build a scene. A scene contains everything that we need to understand our model itself. It also generates the thumbnails. You have a specific thumbnails for the Revit design itself. When you have the icon of the RVT file format, if you see it on your file explorer, for instance, you can see an icon on the design itself. Or maybe you have a thumbnail that refers to a specific sheet with information for the model. Model Derivative API can generate that. And it can also generate, in the case of the Revit file itself, multiple views. What is a view? We have in the Revit file the 3D view, which is the default view containing all of the elements inside our model, the walls, the floors, and so on. And we can have also multiple 2D views. 2D views refer to floor plans of our models. They can be also sections of our models and can be sheets also from our models. Inside Revit, we have an option called Publish Settings. Through these Publish Settings, we can control which views are going to be generated as soon as we post this job right here. We are going to use a default file, so if I'm not mistaken, it generates the 3D view and a few 2D floor plans and viewables. This is also controlled by this metadata right here, this option right here. As you can see, we are specifying the types of views that we want to generate. In this case, there's an error in our tutorial that's showing 2D 2 times. So let's change that to 3D. With that specified, we are going to generate both the 2D and 3D views from our design as soon as we translate it. And we also have the getTranslation status function. Why do we have this function? We have this function because, as I said before, this translation is a translator on the cloud, is an instance in the cloud on our server to go read this design, the input design that you have, and generate the proper information. Depending on the complexity of your model, and here by complexity, I don't mean only the file size. I mean the number of geometries, the number of metadata. A small file can have a huge amount of data, all right? So depending on the complexity, it might take more or less time to translate it. And we can only take advantage of this result to render in the viewer or extract information when this translation is done. That's why we have this method right here. We are going to trigger the translation, and from there, we are going to keep calling this method, this function right here. From this result, we can see, oh, we should wait a few more seconds, and then call once more. Oh, we should still wait a few more seconds. It's not ready yet. This information is available inside a file that we call the manifest. The manifest, we have the progress of the translation, all of the translations that are available. A Revit file can generate an SVF, DWG can generate an XC. All of this information about translations done by model derivative will be accessible by the manifest file itself. And in this case, we are only using to keep track of the progress of this translation. And once it is done, we can render the design in the browser. All right, we have the logic for uploading and translating. Now we need to add the logic for, now we need to add the controller, which is the connection from client side to server side. This is done through this file right here, modelscontroller.cs. So we copy its name and paste it inside the controllers folder. Right-click the controllers folder, select Add Controller. I'm using the API controller empty. Let's select Add. Paste the name from the tutorial. And now we have a content that comes by default once more. Delete the content that comes by default. Copy and paste the content from tutorial. Let me just drink some water. Okay. Now let's check what we have here. We have the endpoints to retrieve all of the models available. And this is going to show us all of the models that we have inside our bucket that we specified. We have endpoints to retrieve the status of a specific file itself that we translated. The file is always referred by what we call the URN. URN is the address of a file that stays in a specific forge bucket. It contains the name of the bucket / the name of the file. It has additional information, but mostly it contains that. The name of the bucket is the name of the file. Since the name of the bucket is globally unique and the name of file inside the bucket is also unique, with both of these information, we can point to any specific file in our platform. If you have a bucket with your client ID that is unique, and inside the bucket you uploaded the model A, it's going to generate a URN just like Autodesk.something your client ID / the model a.rvt. With that, you're going to call the endpoint to translate the model. And then you can also call the endpoints to get the status of this translation. You can also call manage this file through this identification, all right? The URL is always the identification. And the way we do that is that we need to base64 encode this URL. That's why we have a specific method for that. If I'm not mistaken, it's right here or on the client side. It should be on the client side, but it's always good to know that this is encoded. So this is what we're doing right here. This is the case where you don't have translation status available because this file was not translated. We have a form, a class to help us take advantage, upload the specific file itself, and this method right here to translate the model. The way this sample is built, sorry for that. The way this sample is built is that as soon as you upload a model, it's going to upload, and after the upload, it's going to generate a translation, one after the other. So if you upload a model separated from this extension, you won't have a way to translate it by default because this extension is doing both things in one go, is uploading and translation. After that, we can take advantage of this translation to render in viewer. All right, and with that, I guess everything is covered. Yeah, bucket key, URL. And we can try out all of these endpoints. Let's start debugging. I just started. And let me add a breakpoint. Since we don't have any model, we don't have a URL to reference right here. So the endpoint that we can use in this case, let me grab the models control, is this one right here. We can reach this endpoint, and it's useful to retrieve all of the models that we have on our bucket itself. There is another important information right here. I think I missed that when I was explaining, is that here we are specifying the bucket key, and we have a specific verification. If the bucket key is null, in our case, it was an empty string, this constructor for this class is going to use as bucket key our client ID, the prefix of our client ID, dash basic dash app. All right. So this is our bucket. This is the bucket that we are going to use. Now let's check which files, how many files we have on our bucket. That's done through this endpoint right here. So to access this endpoint, we can add /API/models. So /API/models, and we are there. Let me add another breakpoint right here, and let's go inside the get objects function. Right now I'm inside the models, the for service for managing the storage of our files. And now I'm going to, first of all, before I retrieve the object inside this bucket, I need to ensure that this bucket actually exists. And to check that, I'm going to use the bucket key. As I said, there is a verification. Since we added an empty string, our bucket key will be this one right here. It's not friendly, I know, but it's a way to ensure that our name is globally unique. You can do something like client ID dash your name or something like that. Or the purpose of this bucket, right? For instance. Now let's go inside this function and share bucket exists. It's going to return to us the internal token. In this case, the internal token, it has the scopes to manage everything. Now we are going to create a new bucket API variable, add a token as configuration for that, and we're going to query the details of this bucket. This is the first time we are querying details or basically doing anything with this bucket. So it doesn't exist, right? As it doesn't exist, it's going to raise an error right here. Okay, it was expected because as you can see in the reason, the bucket was not found. This is the reason that the message that the API server sent to our application. I couldn't find this bucket, so I need to create this bucket right now. Once more, the bucket is just like a folder to store. The purpose of the bucket is to store the file, our designs. The error code was 404. 404 means not found. And now, since we don't have the bucket already, we can create a bucket using this name. And as soon as you create a bucket, we need to specify what we call the policy of the bucket. Every time you create an APS bucket, we need to specify a policy. And we have three options of policies. We have the temporary policy, the transient policy, and the persistent policy. And they are going to tell for how much time our bucket is going to store the files. So with temporary policy, it's going to store a file for 24 hours. We have another one for storing the files for 30 days. And the persistent one is to store the files for forever, until you delete the file or the bucket itself. It is good to leave it like that in this sample because since we have a trial account, we have a limited amount of 5 gigabytes of storage. So this is a good way to keep cleaning our buckets so we don't reach our limit, all right? So let's create a bucket. We just created, and with that, we ensured that now we have a bucket available with this bucket key. Now that we have this bucket available, we are going to retrieve the internal token. Once more, this function is not generating a new token. It's just checking if the token is available. If it is, it's still valid, sorry. If it is still valid, it's going to return that for us. If it is not valuable, then it's going to generate a new one. Okay. In this line right here, we are going to retrieve all of the objects stored in this bucket. Since we just created this bucket and didn't upload anything, the response should be empty. So we don't have any object inside this bucket. So we are going to bypass this while right here and return the results. In this case, 0. We have nothing to show. So there we have then we have a return, a function to return the bucket object to our client side, and then our client side can show the result in all of the objects available on our browser. In this case, it is an empty array, meaning that we don't have anything to show at all. Okay? So far, so good? Makes sense? This example right here shows a lot of content because this bucket, as you can see, it has multiple files. But since we are creating one from scratch with an empty bucket, we have nothing to show. Any question? Everything understood? Let me show you the policies that we have. I spoke about the policies. If we go right here, On the retention policies, we have all of the policies that you can use when we are creating the buckets. All right, transient, 24 hours. After 24 hours, it is going to automatically delete. This is the one we are using. Temporary for 30 days. Let me just ensure this is the one we are using. OSS controller. Sure. Oh, we're using temporary policy. So our bucket that we create with this application is going to store the files for 30 days. And we also have the persistent policy to store the files for forever until we delete the bucket or the file itself. And also until, if you have your account valid. If you leave trial and don't move to subscription, there is no guarantee that the file is going to remain that forever. You need to have an active account. If you want to change the policy, feel free to go here, just delete it and select any of the available options. I'm gonna use transient because I will have this. I created this app just for today. So, oh no, I actually I don't have this option anymore because I already created the bucket. So, yeah, it's like that. Can we move to the final step of this application? All good? If you could please add a response. Any reaction? Any reaction, team? Okay, so let's move. Step 4. Now we'll take advantage of viewer and we are going to build the user interface of our application. On these steps, we need to add the viewer logic. We are going to do that through the usage of a JavaScript file for the viewer. We have the logic for our application that's done from with a different JavaScript file, the main.js, and we have the HTML page. It will be called the index.html. This is a one page application, and the styles from main.css. At the end, we are going to test it. I'm going to show you how you can debug your application and how you can take advantage of specific viewer methods from the console of the browser itself. And I'm going to show you a few extensions. If you want, you can add some cool extension and play around with viewer itself, right? Let's go. Now, next step, viewer and UI. Okay, now this is specifically for Node.js, so we don't have to worry about that. And first of all, we need to create the app for the file for the viewer logic. It's under, since we are working now with static files, we're always going to be adding content inside this www root folder. So let's go under the folder, wroot folder. Oh, sorry for that. Right-click that folder, select Add New Item, and we can filter by JavaScript. Paste the name from our tutorial. JavaScript is good because it comes empty. So we can copy and paste the content from tutorial. Basically here, this is the way, this is the path that we have to obtain the token from the server side. This is the only call that we are going to make from client side straight to APS server, right? As you can see, this function here, it's using the fetch function from JavaScript. to reach the endpoint that we reached on the beginning of this tutorial. Then it's going to obtain the access token and use it later to download and render the translated model in the browser, all right? This is the logic for viewer initialization. We have here the initializer viewer. We have a configuration. When we initialize the viewer, we can pass specific configuration to control the offsets of models, to load multiple models. We can control the position of our orientation. We can translate the model orientation. We can also specify which extensions viewer is going to use. I'll have a few words on extensions as soon as we start playing with that. Right? We have to also set the theme and start the viewer itself. After we start the viewer, we have also a function to load a specific model. Loading a model is adding the content of a specific design inside the scene of the three-dimensional scene or two-dimensional scene of our model. And that's done through this function right here, taking advantage once more of the URN of that model. URN is the identifier containing the name of the bucket / the name of the model. And after that, as soon as the model is loaded, we can take advantage of, for instance, this on document model load model is successfully loaded. All right. Once the model is loaded, a model comprehends a design with multiple views. As we are talking about a Revit model, it can contain the three-dimensional view, it can contain the two-dimensional views referring to sheets, to floor plans, or to sections. Through this line right here, we are loading the specific root default view that we have. For Revit files, it usually is the three-dimensional view, or if you don't have the three-dimensional view, for instance, maybe you have one that is shown by default as soon as you open Revit. So viewer is going to use the same one as default geometry, all right? So let's go. Now we have the logic for viewer. Now we need to add the logic for our application. So we add this main.js file inside the www folder. Right-click www folder, select add, new item, JavaScript file. Now we add main.js. And can you still hear me? Fine. I think my Can you hear me right now? Oh, nice. Okay. Oh, I think I was using the AirPod. Oh, now you're using this one. It should be way better. Okay. Now let's go back. Main.js.
this is the logic for our application. And in here, we have the logic for all of the actions that the user can take from the user interface itself. As soon as you select a specific model from the drop down, as soon as he clicks the upload button to upload a model and then triggers the translation, everything is covered in this JS file. We have a notification on top of viewer itself to show the progress of the translation, and everything is done basically inside these methods right here. All right. Here I have the drop down being added with all of the models that we find from the request that we made. Remember the first one to retrieve all of the models, then we have the results and add those to the drop down that the user can select. As soon as you select a specific one, it's going to call this onModelSelect function right here. And this onModelSelect function right here is going to check if the model is translated, if the translation is already done through this endpoint. If it is done, depending on the status right here, is going to either load the model in the viewer or keep calling after a few seconds. If it is progress, it's going to show the notification, oh, this model is being translated, the progress, and then it's going to call this function once more after 5 seconds. So if a model takes 50 seconds, we are going to call this 10 times. We call once, oh, the progress is 0%. 5 seconds later, calls more, oh, the progress now is 20%. Calls once more, the progress is 40%, until we have the progress of 100%, and then we load the model itself. We have also the function to upload the model, and in this case we can upload zipped files. Viewer, model derivatives, automation and viewer can handle zipped files. If you have references for a specific model, you can add those in a zipped file and translate the zipped file folder with specifying which is the main model itself, right? And that's mostly what it is doing. We have we are managing here a notification to keep track of the progress and so on. After that, we have also our HTML file with the structure of our main page, the single page of our application. To add that once more, since it is a static file, we need to add that inside the www root folder. So right click the www root folder, select add new item, and now I can filter by HTML page, and once more, get rid of the default content, copy and paste the content from tutorial. And in here we have the reference for the viewer library. Viewer, as I said before, is a JavaScript library built on top of 3JS, the open source project, and it can be referenced by your application, by the HTML page through this reference right here. We have here the style for the CSS for viewer and the JavaScript for viewer with all of the logic to render your designs. And as you can see right here, we have 7 dot star. What that means, viewer have multiple versions being released on a basis on a basically weekly. We have new every 2 weeks, something like that. We have a new version of viewer itself. To keep track of that, we can go inside our documentation. If we go under viewer, change history, we have the version 7 change log, and these are the versions with all of the dates, what changed, what got fixed, and so on. And this is the most recent 7.8.7.80. In a few weeks, we probably will have the 7.81. So with these 7 dot stars, it means that our application is always going to download the most recent version of viewer library itself. So this is good for our development because we are always going to use the most recent content. But once you move to production to deploy your application, it is required that you remove the star and add here, fix the version of the viewer that you developed your application. Because on development, you are making changes, you are debugging, you are ensuring that everything works. Once you move to production, you want that to work all the time. You don't want that to change on since as soon as we deploy a new version of viewer. So as a good practice, always when you move to production, replace the start with the version that you developed your application, right? We have the reference for the CSS, the JS, and the divs for the viewer, and the overlay, which is the notification itself. And we have also the input of our file, the button and input for file. We also have a logo right here. This is looking for logo.png file inside the W root. I'm not going to add a specific logo, but if you want to add the logo for your company, this is the place to go. You just look for a PNG file of your company or of your preference, and just right click root, select add existing item, and add the logo of your preference. All right, this way you can customize this application in an easy way. With that, we are only missing the styles for our app. This is done through the main.css. As it is also a static file, we can right click www folder, select add, new item. This is a style sheet. So we replace the name from our tutorial, main.css, get rid of the default content, copy and paste the content from our tutorial. All right, as you can see here, we are controlling the style of our application, overlay to manage our the what's going to be on top, our notification of our viewer itself. This is done through z-index, header and models and so on. Everything that we have on HTML, we are controlling the styles through this right here. So let me clean this up. We don't need the static files, debugging. And with that, we should be able to load our sample, right? We are also missing the favicon and the logo. Feel free to grab those here if you prefer. I'm going to run without those because they are not required. And if we start debugging, we should see how our application works. All right, simple viewer. It is loading, and this is how it works. It starts the viewer, and then we have our application with all of the apps that we have available. In this case, we don't have any app. So to make it work properly, we need a design, we need a model, all right? First of all, before we upload a model, Let me add a few breakpoints. Let me add a breakpoint as soon as we upload a new model. Okay, right here. Actually, let me add it under the controller. Models controller. This right here. This is where we upload a model. All right, and now we also need to use a specific model for testing. So in this section right here, you can take advantage of Revit in the version 2022 or AutoCAD sample projects in order to test this application. Let me open this in another tab, and I'm going to use this one. This is the most common file, Revit file. We use that for all of our samples. So we have a great chance of finding this sample file in one of our proof of concepts. Any questions so far? Now it's going to get interesting. Now is the interesting part. We use viewer a lot, and in the next session, the design automation. All right, now we open our application. It's going to obtain, to check all of the models that we have available, start the viewer without loading any model because we have nothing to select here. Now if you click upload, we have an input option to upload a design. I just downloaded one, so I can go over here, RAC basic sample project. This is the fourth one. As you can see, I use this sample a lot. I can click open, and this is going to upload the model. To upload, it's going to reach our endpoint, and specifically through this function here, to upload and translate the model itself. First of all, we need to upload it. So we use the for service through the upload model function. And before upload, we need to ensure the bucket exists. We ensure the bucket exists. Now we grab the internal token. The internal token is the one that has the permission. And then we upload the files. The file in this case. It might take some time depending on the size of the file. The uploading depends specifically on the size of the model that we have. The translation depends mostly on the complexity of the model. Okay, since something is broken with this endpoint right here. Let me try once more. As you can see, the file was not uploaded. Otherwise, we should be able to see it right here. So let me upload it. It is 18 megabytes, something like that. If you have any questions, feel free. Let me try just once more. If not, I'm going to use a different sample. We can use three samples, three ways. Oh. All right, could not upload it. Let's see console. Okay, there's an exception here. Let's see what happened. Okay, internal server error, so we don't have much more information. So it was a connection timeout. There's a timeout if a connection takes too long. That's what's happening right here. So to upload this file, we can do it in multiple ways. We can do it through Insomnia, through this sample that there's probably something going on. I don't know if probably my connection is taking a lot of time since I'm streaming this, but we can also use this sample right here, OSS Manager. Even for this sample, it's taking a lot of time to open. So through this sample, the way it works is that is a way online to manage your designs, manage your buckets by using your client ID and client secret. So I can simply add my client ID secret, select login, and now I'm able to take advantage of all of my buckets. A bucket can be in two regions. We have two regions available for you to store your designs. It can be US or EMEA. So as I'm using US, this is the bucket that we created with temporary policy. And if we expand, we can see any object. If we right click on the bucket, we have an option to upload a file. So let's go under downloads, upload our design, and it's going to upload. Okay, and after that, if I select, it's going to start translating this file for us. So that's everything that we need from this sample. Let me share that with you if you have similar trouble. I can save this debugging for later. Right now, let's keep debugging our sample. We're about to run out of time in a few minutes, so I don't want to keep you from lunch. Now, if we run the sample again, we are going to be able to see all our object that we just uploaded. And as this translation started a few seconds ago, it's already at 65%. What's happening now is that it is checking each 5 seconds the status of our translation. And to check that, it's calling this using this method right here, together with the URN for this model. And the URN is base64 encoded. We can check that through this page right here, for instance. This is basically how the structure of a URN. We have the object, the bucket key right here. This is the bucket key, and this is the file, Revit file inside our bucket. All right. This method is using the URN to obtain the progress of our translation, and it's going to return that right here. Let's check that actually. Oh, status as success already. So it means that the progress is already 100%. So if we keep our app running, we should be able to see that our application started loading our design using Viewer itself. All right. And in here, it's going to load the default view for this Revit file itself, for the SVF itself. And as you can see, it starts with the three-dimensional view. But as I said before, this three-dimensional view is just one view for this whole model. This model can contain multiple 2D views and multiple 3D views that you specify. To access that, we have one extension that is provided together with Viewer. This is called Document Browser Extension. And we loaded this extension by adding this extension name right here, Autodesk Document Browser Extension, right? So through this extension, we can go through each of our available views. In this case, I have the 3D views and every sheet view that got generated for this design itself. For instance, I can go through the plan views. And in here, I have access to both two views of this model inside a sheet view, all right? And as those are referring to the model itself, I have access to all of its properties, all right? And I could do a lot of things here. I could add more extensions. I could clear this extension. I could manage the color of these elements and anything that is available on through the Viewer API, through the Viewer methods itself. If you want to check with more details, we can go simply inside the Viewer API, and in here, API reference, we have all the documentation for the methods, how we can override colors and so on. And we also have these Viewer essentials right here. How to write an extension, customize the toolbar, check the difference between two models, take advantage of these features that comes by default. We also have on our GitHub a specific repository with multiple extensions. Let me stop that from running since we finished our application. And we have all of them available to use through this address right here. So in this GitHub, you have access to all of the source codes of these extensions, and you can test those in this address right here. Let me share with you. This is the address of the repo, and this is the address of to test the extensions. We have extensions, for instance, to take advantage of georeference for this model itself. Revit files can be geolocated, have geolocation information, so you can take advantage of that inside Viewer. And as this sample shows, it's taking advantage of this information together with Google Maps API to position this model itself. It's using the bounding box of this model together with the positioning to show in this map where this model is located, right? We can also, for instance, control the camera for this model itself. In this case, it is starting a rotation of the model. We can combine that with the other features, such as exploding the model. We can extract information of this model to a Excel spreadsheet. We can have this extension, this transformation extension, to control the position of specific elements. In this case, for instance, I can move specific elements from my specific 3D scene. This one right here. Let's say I want to test this roof without this grass. All right. It's important to know that this geometry, this metadata, these are all generated from the input file itself. When we modify this information, this geometry, everything here, when we add information inside the context of a specific application, we are not modifying the root file. We are not generating a new Revit file. We are always working with the viewer derivatives itself, with the SVF format itself, and it cannot be changed. The SVF from the bucket will always be the same file. If I go here and load it once more, for instance, it lost all of the modifications that I made. All right. So it's good to know that this is a fixed, this is a static file that is stored inside your bucket, specific bucket. All right. So if you want to do if you want to modify this model, you need to use the API that we are going to see in the second session of this tutorial, which is design automation. All right. Before we go there is one extra content that I want to share with you, which is the playground, the viewer playground. If you go under playground.autodesk.io, you should be able to select first of all one specific model, let's say architecture, and one specific feature that you want to test. Let's test custom geometry. So in here on the left side, we have some snippets to manage in this case, the geometry of this model itself. If we check right here, this one is using hotkeys to manage the color of the elements inside the viewer itself, or to override the materials of some specific elements. So for instance, let's say I select this one here, and it says there is a O override key, O hotkey. If I press O, it will override the color of this element. So let me press O, and right now this element is red. How it did that? It did that through this override elements color function right here. So this override elements color function is using a viewer method called setThemingColor. And this we use a variable that controls the color and the DBID, the reference for a specific element that I want to change the color itself. In this case, I'm using RGB factors. In this case, it's 200, 1010, which is mostly red color, and I'm using the way the sample manages that by the element that I selected. In this case right here, I was selecting this wall. So each of these elements inside the viewer, inside my scene itself, they have a specific ID. Through this ID, I can perform most of the task, most of the methods that viewer grants us. All right. The other option here is to, in this case, in this sample, is to replace materials. So I have windows here, they are transparent, and I have a concrete roof right here, concrete floor right here. So I can use the hotkey C to copy the material of this element, and the hotkey P to paste the material to this other element right here. And as you can see now, this window is not transparent anymore. It reproduces the same material that I had before. I can do the same for this one right here. Okay, and also this one right here. And this is going through the specific selected element materials, grabbing that and applying that to other elements. You can check all of that and multiple samples on how to override the property panel and mostly the basic customizations on viewer through the use of this playground.autodesk.io. All right, this is still on beta, if I'm not mistaken. So if you find any bug, anything that it's not working properly, please just let us know. But it should be good enough to keep to start taking advantage of viewer in a higher level without only viewing the model, but controlling the camera, the orientation, the geometries, and everything that is available through the viewer library itself. Let me paste it for you. And that's most of what I wanted to cover with you today. So today not, in this first session. Do you have any question, anything that you want to know how to do, any specific feature, any workflow that you're working on that you want to have a proper direction? No? Are you there? Are you still there or got bored? So you have the lunchtime to think about it. Oh, the same error message from uploading, Joseph. Which part, Joseph? Fail to upload the model? Let me check. Joseph, it is when you try to upload it.
Hello? Can you hear me?
Oh yeah, for large models, we need to manage the uploading chunks. Both upload and download must be in chunks. We have that available for the .NET SDK version 1.9.7. I'm not sure if it is available for Node.js, but yeah, just for the samples, work with first of all with smaller models. And if you want to try the new ones, you might need to replace a few contents on the samples. I'll ask that to my friends if the samples are handling really large models, and I'll reach you back with that. Okay. So that's it. I see you in 1 hour and 10 minutes for design automation for Revit. I'll be using mostly Insomnia. I'm not going to build any app bundle from scratch because it's going to be too much, but we have a few app bundles that you can use, and we have a few projects with the source code that you can use to take advantage, to leverage on that, and build your custom integration, your custom workflow with design automation. And that's mostly it. We are going to use Insomnia with a collection that I'm going to share with you for to modify our models. It's not going to be based on the tutorial that you have on Forge tutorials. It's a different one, but I think you'll find it really useful. And after that, I'll share with you a few samples that we have on design automation itself. All right. If you have any questions, you have time to think of a workflow using Viewer itself, managing models. Maybe you want to use a different connection to show 5 dimensions of a model, connect with cost, connect with execution phases. So bring everything that you have, and I'll find the most suitable sample for you to rely on. All right. With that, I'll see you in 1 hour and 7 minutes. We have 7 extra minutes to lunch. And that's it. Thank you for your presence. See you soon. Now I'm started recording once more. And let's begin with the second part of this second session of this class. I'm not sharing the screen, right? Now I'm sharing the screen. Are you able to see my screen? Okay, thank you very much. Now let's begin the session 2 of these APS, Autodesk Platform Services, also formerly known as Forge. And now we'll cover design automation. This is the focus of this specific session that we have right now. A few words on design automation itself. Let me just check my audio. Yeah, all good. A few words on design automation. Design automation is the API that will allow you to access the automation capabilities of the Autodesk core products as cloud services. So as of now, without design automation, we have a way, the common way to modify designs and to view. We have seen another way to view designs, but with I presented to you so far, if you want to modify a model, you need to download it, go through the specific product itself, perform the modification either manually or through a plugin, through a script itself, and then upload the resulting model. And that's the same if you need to perform an extraction of data that's not present in the SVF conversion. all right? But for most of the tasks, for many tasks, actually, you don't actually need a person going through the file, opening it on a desktop application, and that can be done automatically. You don't need to have this bottleneck, right? Basically, almost any task that you can automate on your desktop application, and we'll see a few examples in this session, can now be automated at scale using Design Automation API. When you want to upgrade models, if you want to perform a modification in batch for multiple files, something that you don't need the user interface of Revit itself or any of the supported products, you can get work done quicker and more reliably. And what's more, because Design Automation API is a web service, you can connect this tool with your business systems to provide complete workflows that can accelerate work processes, improve business flexibility, and generate new business opportunities. This is just a diagram show basically the workflow that we have. We will have basically inputs and scripts and tasks that you need to do. And in the cloud, you have one of the supported engines for design automation performing the task, generating the results. That can be a report, can be a view extracted, can be another modified file, or any of the supported, anything that is supported by the specific product API. So far for design automation, we have support for these four products, these main products. We have support for Revit, Inventor, 3ds Max, and AutoCAD. We have also support for AutoCAD, including Civil 3D, right? So this is on beta, still on beta right now, but you can take advantage of Civil 3D API inside as part of the AutoCAD engine. And as I said before, if you have a task that is repetitive and it's covered by the specific products API, if you have that, design automation is a good opportunity for you to leverage your workflow, right? In this class, we'll focus on Revit itself, and I'm going to explain all of the steps for you to take advantage of the bundles that we have available, for you to build your own, convert your app bundles, the plugins that you might have into app bundles that you can use together with design automation, and some specific tools that we have available for you to debug, for you to deploy, and for you to develop your app bundle. Just before we jump into more details, is anyone here familiar with any of these products APIs? Revit API, anyone here familiar with Revit API? No? Okay, so I'm not going to have a deep dive in Revit API, but if I'm not mistaken, there are a few classes on that on this event. So yeah, if you want to take advantage of any of these APIs, design automation is the way to go. We have this diagram that's really useful to have a better vision of what design automation is exposing. The important part here is to address that design automation is not exposing these products APIs as RESTful API calls. We don't have endpoints to take advantage of methods from any product API. What we have actually, oh, sorry for that, that was a mistake. Okay, what we have actually is inside a sandbox, inside a virtual machine, an instance in the cloud that design automation is running, you're going to have stored the specific code to perform the task that you want, and you have the server for the specific engine that you're going to use. In our case, we'll be focusing on Revit API itself. So we'll have our code, let's say, to upload files from input version to a most recent version. So we have our code to grab the input file, open it with Revit, and then save it on a most recent version. This is your code you're going to write, generate the app bundle, and upload it to be used in this instance, in this sandbox environment. This sandbox environment will have the Revit server, and we'll have the support of, we have access to the Revit API to execute your code. This all of these sandbox is accessible through Design Automation API. You're not going to make a request with the code, the specific code to execute using your Revit API. You're going to upload your app bundle that is a derivative from the plugin, and then you're going to use this automation API to call the execution of this app bundle on a specific file, on a specific input file, generating outputs and keeping track of the progress and the results and everything that is available. Design Automation API is common for all of the engines. So we are going to see in details all of the terminology for design automation. But what we need to be clear right now is that we are going to use RESTful calls for design automation using Design Automation API that are the same for any of the supported engines that you have. The main difference will be in the app bundle and the engine that's going to be executed, all right? An important thing is we are not exposing the APIs as RESTful calls. We are just reaching the APIs inside this sandbox, this virtual machine, all right? Any questions so far? Okay, no questions. Now let's take a look at how is the workflow for to run a job on design automation itself. First of all, you'll have your code, your specific code that can be any instruction covered by API to perform anything that is available, and you have the specific source data. If I have a code on the using Revit API, I usually want to take advantage of a .rvt or .rfa file. I want to, I don't know, add some families into a project, modify a project, modify a family based on its parameters. Or I can also take advantage of the Revit possibility, Revit compatibility with IFC files. So I can import an IFC file, perform an automation on this file, and generate a Revit design. Right? So at the end, at the beginning, we always have the code that with what we want to do and the source data. From there, we are going to run this code that we have against this data in the cloud using one of the design automation engines available. And once more, it's always good to remember, we have AutoCAD, Revit, Inventor, and 3ds Max. AutoCAD including Civil 3D. After that, after the execution of this job against this input data, design automation is going to generate the result. And the result can be a report. For instance, I can query specific information on a design and return everything I have read from in a JSON file or in a text file, anything available. I can also export the views of my design as PDFs, print as PDF. I can export as IFC from a Revit file, or I can generate a new source, a new file with the content modified. Maybe modify the parameter. Maybe I added some families on specific positions. So anything covered by the API is available here. Now that we know the workflow, we have the files and the orchestration, the tasks, we take it to the cloud. The design automation instance runs our tasks and then generate the result. We need to know how these data, this input and output, can be accessible. How this can be available. What's most important here is that in the first step, you need to make your data available in the cloud. And in this part, it is different from model derivative itself. If you remember from session 1, to generate the translation, to trigger the translation, the file needed to be in a bucket managed by APS, managed by Autodesk. Now, this is not how it works. You can make your data available in the cloud in any storage location. It doesn't need to be specifically in a bucket managed by your app. You can have your design available in Azure, Google Drive, Dropbox, or any other storage. It can be even your own AWS bucket, right? Or the Forge bucket. It also works. From there, you need to obtain links so that design automation can use those links to grab that data. Design automation is a sandbox in the cloud, so you need to provide our environment, our instance, a way to grab this data. It usually is done by taking advantage of a assigned URL. Assigned URL that this job can go and grab the input file, right? With that, design automation is going to download the input file via web request and run your code against this file. After running the code with the result, design automation is going to upload it also through a web request. And this upload can be once more in any storage available, as Azure, Google, Dropbox, AWS, any storage, even including the APS buckets, the buckets that we created, for instance, in our first session, right? The important here is that when you are running the code, the design automation instance, the item on your inputs generate the outputs, you have at one point both input and output available on our servers, on our backend. So what's important here is that both the inputs and output are not stored. They are going to be downloaded, they are going to be processed when we run the code, and then we are going to discard everything. As soon as the job to perform a task is done, the files are discarded. We are not going to store those. They are only going to be available in the storage that you specified. Clear? This needs to be really clear. All right. Just like all of our API, all of our services, the ones that I presented to you today, design automation have some specific terminology. First of all, we have the engine. The engine is the executable used to batch processing. Is actually the actual Autodesk product, including the specific version. I can run a task using AutoCAD version 2019, or I can use Inventor 2020 for a task, or Revit 2022 for a specific task. You can specify both the engine and the specific version. With the specific version, automatically the API compatible is going to have changes, right? With the engine defined, we need to specify the activity that we are going to use. The activity specifies how and what is going to be executed inside this sandbox, inside this environment in the cloud, right? It specifies the number of inputs, the number of outputs, how are those files, are zipped files, they are required, they are optional or not, and also it specifies the app bundle that we are going to use. All right. Now that we know engines, we know the activities. Now when we explain the activities, we referred about the app bundles. The app bundles are the actual plugins, can be a plugin, an add-in, a script, is basically the task that you are going to use taking advantage of the product API in the cloud. For Revit, for instance, it is a plugin that you convert to an app bundle inside a folder with the add-in and the XML file explaining where the resources are, right? With all of that, we define the engine once together with the activities in the app bundle, and with that combined, you can run multiple work items. So the work item is the job to run on an engine in Forge, in APS. So basically, I can have one engine, let's say Revit 2022. I can have an activity, and in my activity, let's say I specify that I will have an input file, I'll generate an output file, and I'm going to run against a specific app bundle. In the app bundle, I specify that I will grab the input file, open Revit, import, open this project with Revit, upload it to a most recent version and save it. So I have all of this orchestration defined once. Please note that when I said about the activity in app bundle, I didn't specify any input and any output. So as soon as we specify all of these three together, we can run a work item. This work item is the execution of all of that together for one specific input file, generating one specific output file, a specific result file, right? So let's say if I have all of these tasks, sorry for that. Let's say I have all of these tasks to upgrade the Revit version, and I run this again 100 times. I'm running always the same activity bundle and engine with 100 different work items. The work item is the execution of all of this orchestration against a specific file. All right, that covers a lot, but before jumping to design automation, we have another feature that is really useful, which is the callback. When you run a job on design automation, it might take some time depending on the complexity of your task and the complexity of your model. So just like a model derivative, you need to wait some time to take advantage of the result of this execution. First of all, we have a queue with all of the tasks that are coming from all around the world. And when you submit a job in design automation, it's going to be this job is going to join the queue, and once he joined the queue, he will start being processed. Design automation is going to download the file, process against your code, and then generate the result. To know when this file is done, when this execution is done, you can take advantage of the onComplete callback. The onComplete callback calls your endpoint, calls your app, saying that, oh, this job is done. You can take advantage of the results. We also have another callback called onProgress callback. This one calls your endpoint every 20 seconds, if I'm not mistaken, with status about how your project is going. And we also have the on-demand callback. On-demand callback is a way to add, to provide additional input during the execution of your work item, of your execution, of your job, right? That's enough of terminology. I hope it was not a lot. Now we can see design automation in action. Before that, I want to share with you a few tools that we have available. We have the Design Automation Manager, Postman Collection. I'll be using Somnia through a link that my colleague provided to download the collection. We also have it covered in the Visual Studio Code plugin. This is really good. This plugin covers most of our services. So if you're using Visual Studio, I encourage you to take advantage of that. And now let's check a few samples on design automation. First one that I want to share with you, let me see which one, is from our tutorial. If you go to our tutorial, our platform, under getting started, it's going to redirect you to our previous tutorial. This previous tutorial has a specific section for modify your model. So this tutorial covers step by step on how to build a basic application, just like the one we did for first session, but this time to modify a design using design automation. So you have everything covered. Create a server. It is using ngrok to expose your local host in order to take advantage of the incomplete callback. And if you go, for instance, with .NET Core, you have all of the steps to create your server, the controllers that you're going to need, the user interface, and everything basically. And then we have this section to prepare a plugin. All right. I'm not going through this tutorial because we do this a lot on our bootcamps, and the last one is already recorded, available on YouTube, so feel free to go there and take a look. I'll go through the tutorial from Insomnia itself, where you can take advantage of the collections to run basically any app bundle available that our advocates built to see how it works, and maybe even modifying those. So yeah, it's more I thought it would be easier for us to start with design automation instead of building another application. But if you want, again, there's a video on YouTube on that. I can share with you later. First one that I want to share with you is one sample that I already spoke during the presentation. Is the upgrade files in Revit itself, taking advantage of Revit itself. This is pretty simple, and as you can see from this thumbnail itself, is taking advantage of your login, your account, to connect with a hub, a specific hub. In this case, it should connect to ACC. Let me see if this is working on Heroku. I'm not sure. I have a long time since I don't try this sample. Oh, it is working. Okay, so you can sign in, select the specific source folder, select a specific format of file, and upgrade it to another version, another Revit version. This is pretty simple. What this is doing is actually just selecting the engine that you have. Let's say you select 2022. It's going to the cloud, grab the input file, open it with Revit 2022, save it, and then upload it to wherever you specify. Just like that, right? Because it is actually the behavior of Revit itself. If you open a previous file on the most recent version, it's going to automatically upgrade that version. So since this sample is just to upgrade, that's exactly what we need to achieve. Let me share with you this link. And the second one that I want to share with you is another sample connecting with ACC. In this case, with BIM 360. One common desire for people that use design automation is that sometimes you want to do model checking, model verification. So model verification can be done without a specific user going through the model itself and checking for desired parameters or desired configurations and so on. In this case right here, we're taking advantage of one webhook from BIM 360. From BIM 360 API, we can get notified as soon as a new file is uploaded. This is one of the main APIs available for BIM 360. So from this notification, we are going to grab this file that the user uploaded, run a model check, and grab the result, and based on the result of this check, create BIM 360 issues. For those of you that are not familiar, BIM 360 issues are just a workflow to address problems in your specific design. From there, user can address these problems inside BIM 360 itself. All right. This is using lots of APIs, and the most important part here is that design automation is running a check to verify the collision between the incompatibility between models and columns. This video, I guess this video shows it in details. Right here, basically we are monitoring a specific folder. This is just to keep track. This left part right here is just to keep track of what's going on. But basically user uploaded, it triggers the design automation. Now we have the job schedule. This is just a queuing system for .NET. As soon as the job is done, it found collisions between walls and columns. So it created this sample created issues on BIM 360 based on that, and from there the user is able to see what is the incompatibility through the usage of a custom application, as you can see right here. He also created an extension here to highlight the elements that are causing the incompatibility. In this case, as you can see right here, there are columns intersecting with the walls. So those columns are getting highlighted, right? It's just a quick sample, but shows the power of design automation connected with a product such as BIM 360. All right, after that, we also have another one connected with BIM 360, but in this case, let me share this link with you, otherwise I'm going to forget. All right. And now we have another one connecting with BIM 360, but this time it's using two engines combined. It is using design automation, also apart from BIM 360, it's using Inventor API and Revit API, right? We also have a video. Oh, cool. I have a propaganda here. Let me just wait. Okay, now it's working. We have the same steps here. We are monitoring a folder, a specific folder, and in here we have an IPT file that is being used as an input for a family inside Revit itself. In this case, is the chair. As you could see, that first chat had no headrest. So as soon as a user update this file right here, it's going to trigger a design automation job. This first design automation job from Inventor, using Inventor API, is going to convert from this IPT into a RVT file, and then it's going to trigger a Revit design automation job to modify, update this family inside this Revit project itself. So as soon as we change the chair with the IPT extension, it automatically is going to generate the family and update it inside my project file. This is what's happening right here. As you can see, we have the version 2, and it's going to run a job and update our project to version 2 also. And if we check the differences, we have our new chair updated inside our project, right? Pretty cool, right? This shows a lot of APIs connected. We have webhooks, BIM 360, Inventor, and Revit. This is the real true power of the platform, connecting multiple services. I have another one, which is the one that we are going to use by default, which is this count delete walls for Revit. This is pretty simple. It's just a way to delete all of the walls of an element. So we'll take advantage of this app bundle. And here, if you prefer, you can take advantage of this in the context of a complete sample using the viewer and the a web application itself. Let me also share that with you. First of all, what we are going to do right now, that I shared with you a few samples, is going through documentation, and then we'll have the design automation part, and inside step-by-step tutorials, we have a specific part for design automation for Revit. This is what we are going to do right now. Take advantage of design automation for Revit using, this case says Postman, but we are going to use Insomnia. So any of you here, does anyone have Insomnia installed? Okay, Josie. Molly, do you want to talk, or you're just saying that you have insomnia? Oh, all right. Okay, so for those of you that have insomnia, I have a collection to share for design automation. So is this one right here? Is inside the repo. Oh, let me just answer my colleague. He's asking me how we're going. Okay. The one that we are going to use is this one right here, design automation. And it says design automation D2S3 because recently we had a change on our platform. And this change were to address a new method that we have for handling binary transfer. I mean, uploads and downloads of files. So right now we have a direct access to the file inside AWS S3 bucket. So if you want to upload or download a file, you go straight to AWS and you don't use our proxy that we had before. This is good for performance, but put more responsibility on the developer itself. Enough talking, we just need to go here inside this design automation d2s3.json. We select raw, and now we can copy everything and paste it as a new collection inside Insomnia. Oh, it was already opened. Okay, as you can see, I'm addicted to Insomnia. So we can select create and clipboard. Since I copied the previous collection, it's going to automatically be available right here. So I can select, and this contains the same contents, the same information that we can see on our tutorial right here. You see about this tutorial, task one, convert to Revit add-in. This is not, we are not going to cover because it is a lot, but you have all of the steps, and I can go through the some specific plugins if you prefer, but this by itself, it is a lot of content. When you have time, I encourage you to go through it, create your first bundle from scratch. But yeah, I thought it would be a lot for someone for the first time seeing APS, going through viewer, model derivative, design automation, and generate the plugin. So during this session, we'll always take advantage of already defined app bundles. As you can see right here, as I said in the first session, for any task, for any service that we use, we always need to take advantage of an access token. So from there, we have this test right here, obtain an access token. We have also the create a nickname for the Forge app. This is covered right here. The number is slightly different, but the nickname is that, remember when I said about the terminology, that we have some orchestration that's only defined once, and from there we can run multiple work items. So to make a reference to this orchestration, make a reference to the activity that we are going to define, make a reference to the app bundle that we're going to use, we always need to have what we call a nickname, right? And the nickname by default is the client ID that we have. Through this endpoint right here, we can, instead of every time calling the client ID, using a nickname that we specified. For instance, I can call my nickname as AECtech and add my name. And this will be the nickname that I'm going to use. From there, every time I refer to any activity or app bundle in my account, I'm going to use this nickname. It will be clear as soon as we do this, right? And then we'll have all of the subsequent tasks for this tutorial. Uploading the actual app bundle, publishing activity, prepare for cloud. Our file is going to be on our available locally, but we'll need to make it available in the cloud. We also need to upload the output file that we have available. And after that, we are going to submit a specific work item and download the result, right? So, all good. Let's get back to task 1. I can cover with you the Revit add-in part. But before that, we have any question on design automation? Do you have any workflow? After this tutorial, I'm going to share with you I'm going to use anyone, but just to help to address your questions or concerns. If you have a workflow, please let me know. Now is a good time. If you don't have any question, we can just move to the design automation part, to the tutorial. No questions? Oh, I have just one for you. Anyone here working with sustainability workflow, carbon footprint of models, materials? Anyone here working with that? No? Okay. Let me just delete this. Okay, so let's get started then with design automation. So first it says to convert an add-in to design automation add-in, the Revit add-in to design automation add-in. I don't think you're familiar with the Revit add-in, a plugin from Revit, but basically we'll have to build a C# class. It can be a Windows form. It is that tiny window with common in desktop applications for Windows. And from there, we make a reference to use the Revit API, and it can be on any supported Revit version. All right. Once you do that, and you put this class with all of these DLL in a specific folder, Revit is going to recognize this plugin, and it's going to show from there you can take advantage of the defined text, the defined algorithm that you wrote using the API itself. This code, it works on the desktop, but it always requires the license. It always requires someone in the desktop opening Revit to run your plugin, even if it means only the click of a button and your plugin does everything. It still requires someone opening Revit and going there and running our plugin. Design automation is going to it's not going to take advantage of any user interface. So For design automation, you basically need a task that can be done as soon as the Revit is open with a file. So if you have any reference to Revit user interface API, DLL, that's not going to work. You need to address that. And from there, we have also a specific format in order to this app bundle to be available. If you go through these steps, we have everything that you need to convert. We have a project for that. And in here, we have the namespaces, for instance, that we are going to use, the add-in that we need to specify. In this case, it should be a DB application. And here, steps to convert from external application or external command to the external DB application. We have also an event handler that's specific for design automation for Revit, and so on. Since we are not going through all of that to build our plugin, this tutorial, luckily for us, provides a way to simply download exactly what we need in order to take advantage of design automation. And that's covered right here. If step 8 fails, you can download a design automation capable version of deletewalls.dll from here. So let's select here. Here we have the zip. The app bundle is always this zipped folder. So we can simply go here and download it. As I already had it, it's going to show with this one. And now we can go along with the rest of our application, right? This is what this app bundle is going to do. From the doc, it's basically going to have a collection, retrieve a collection of all the elements of the class wall, and it's going to later start a transaction that's required to modify the model, delete the walls, and commit the modifications. We already have the code that does everything of that with all of its references, and it was everything in this zipped file that we downloaded right here. If you go to build your plugin, we have also this tutorial and this tool that is really cool. So don't miss that. If you want to build your application, go through this step, this task 1, and don't miss this video. It is really useful. All right, first step, we need to obtain an access token. As we saw before, we all know, to obtain the access token, in this case we are using a two-legged token. It's obtained by taking advantage of our app credentials. By app credentials, I mean the client ID and the client secret. It's a simple call to this endpoint, post authenticate with all of our information, including the scopes that are required, and from there we receive the token type, and expires in always 1 hour. So let's do that first. This is the endpoint, but we can't simply call it because we haven't specified our app key and our app secret. So first thing, we need to add our environment variables for Insomnia to take advantage of this collection. Before there, I'm also going to use form here. It doesn't have the multi-platform. Okay. Form URL encoded. Okay, I'm just going to change it to this UI so it is better. And also, I think we have a environment variable for this token. But first things first, let's add our credential. First of all, client ID. So I can go under our environment, and here we have the client secret, the app key, client ID, sorry. And we also need to specify the client app secret, the client secret. For Insomnia, sometimes we need to use, if you want to test three-legged authentication with Insomnia, Insomnia uses a specific callback, which is this one. So if you want to test three-legged authentication with Insomnia, it's not going to be covered today. You'll need to copy this redirect URL as one of the callbacks URL here. Just a matter of adding URL and add this value. From there, you will be able to read it through Insomnia. All right. Now that we have everything set, let me also use one of these scopes as an environment variable. As you can see right here, we have multiple scopes as variables here. We have this scope viewer that only contains the viewables read scope, only for viewer. Scopes to manage data, to manage BIM 360 administration, and scope all that manages everything. A token with this scope all, with all of these scopes added, will be able to perform any task supported by our platform. So just for debugging, I'm going to use this scope all. And now I can send the request. And as the response, we can see our token type, and expires in this case, always 1 hour. So far, so good, right? We have nothing, no news as of now. Second step is the creation of a nickname. Forge uses the client ID that was generated when we created this application, this value right here, to uniquely identify the app that you created. This client ID, you need to provide a way to identify your app between all of the apps available in the APS platform. So design automation can point to your specific activity or to your specific app bundle. When you upload an app bundle or an activity, you're going to specify a name for that. Let's say I'm upload my app bundle with, usually we name the app bundles and activities. It's what they are intended to do. If I have an app bundle to upgrade models, I can say upgrade models app bundle. But I say that, and you can also say that. Design automation need a way to point, I can create an app bundle with this name, and you also. Design automation needs to have a way to point to my specific app bundle. So for that, it takes advantage of the link name or the client ID if you don't specify your specific nickname. This is what we are going to do in this request right here. All right. So another thing to notice is that every request that we are making, we are always specifying the token. We are always passing the two-leg token. And this collection is automated in a way that as soon as I click send right here and generate a new access token, this environment variable is automatically going to retrieve the token from the response of that request. All right. So what I want to mean is that every time I generate a new token, it's automatically going to be pasted as environment variable. So we don't need to keep generating a token, copying this value and passing it to the environment variable, to the token in another request. This is the beauty of these tools. It makes it really easier to debug it, to test the functionalities. So I said enough. Now let's change the nickname. I'm going to call it AECtech JPOM. JPOM is my name. I'm João Paulo Ornelas Martins. So that's why I'm using this, and I hope this is good enough. Okay, we have 200 status code as response. It means that this request has succeeded. So my app now have this nickname. All right. Now let's move to our next step. And in this step, we need to upload the app bundle to Design Automation. App bundle, as said before, it is going to contain the binaries, the actual plugin that our work item is going to use against multiple files. And this is usually for Design Automation, it's always going to be a zipped folder with the DLL, the reference for the proper packages that our plugin needs, and specific contents, a JSON, an add-in that Revit plugins use, and also an XML file specifying the versions and the paths to find the add-ins and the resources required. All right. So in this task, we need to, first of all, if you want to create an app bundle, this is the structure that we have. Inside the zipped folder, we have this second folder for the Elite Walls app. This is the structure. Inside of that, we'll have the package contents.xml. This contains the requirements, series minimum and series max, and they are the versions, the Revit versions that are supported by this plugin itself. It's not 2018. I guess it's using it is supported by Revit version 2022. This is the one I'll try. If not, we can debug it further. We also have inside this app bundle the add-in. The add-in is a text file, is another XML file containing information about the plugin itself, the path to the assembly, the DLL, the class name that's going to be executed, the namespace and the class, the name of the class itself. We need to provide a specific GUID for our add-in. And we can provide a description and also the vendor ID. The type will always be a DB application, right? With that all available, we need to then register a specific app bundle. During the registration, we are not going to actually upload this file. We are going to register inside under our specific hub, under our account, using under our nickname, one specific app bundle that we want to upload. After the upload and the third step that we are going to specify the version of this app bundle, then we can take advantage of this app bundle inside our activities. So the first step, register the app bundle. This is covered right here. And in our case, we are using the Delete Walls app bundle. We need to specify the ID. In this case, it is a name, and it's always good to add a name that actually means what this app bundle is doing. Other than that, you're going to automatically forget what this is doing. Let's call it Revit 2022. So let's change the engine also. You don't have to know, this is important, you don't have to know the engine. I'm going to use the version 2022. We have an endpoint to retrieve all of the engines that are available. Every year that we pass, we have one additional engine, the one that got released, and one is removed from this list. So it's always good to rely on the response from the endpoint to retrieve the available engines. All right. This endpoint is right here. Here, this one. Through this endpoint, you get a list of all available engines. And it is just like that. Once more, the response is paginated, so you might need to call it more than once to get a list of all of the available versions. With that, we can register our app bundle. And once we do that, we are going to receive multiple signatures and multiple secrets and tokens that we need to use in order to upload our app bundle file, the zipped folder, to this storage that got defined. This is basically us saying, we saying to APS backend, to APS server, I want to register this app bundle. All right, and the response is basically saying, upload it to this destination. Use this information to upload this, to make this app bundle available. Once more, the beauty of design automation is that we have a configuration in order to obtain all of this information from the response of that task. You see? So if I go right here to the upload app bundle part, everything is already defined. The key is already here, the content type, and everything is already specified. All right. I only need to update my zipped app bundle. So I can simply click this option, select this option, and select the app bundle that I just downloaded from the tutorial itself. So I just click select. And receive a status code as 200, meaning that our app bundle was uploaded successfully. And now I need to create an alias for my app bundle. What is an alias? Let's go right here. We already registered. The alias is a name for a specific version of an app bundle. As I uploaded the first time, this is the version 1 of the app bundle. I can upload a second version using the same name of the app bundle. Let's say I fix a bug of the app bundle, or I add a new functionality, but it's the same app bundle. It is the same task that I'm doing. So I want to use the same name, but I can do it with a different alias. I can do it improved 1, or I can call it like one version for debugging, one version for development, one version for production. So for that, to address that, we have control over the alias that we need for design automation. In this case, I need to specify my app bundle ID right here, as you can see. So I replace the name that we received from the collection with the name of the app bundle that we are actually using right now. And we replace the ID with some name that makes sense for us. I'm going to call it AECtech. Now we click send. And okay, now all good, 200. Now the version 1 of this delete walls app bundle can be referred as the AECtech version of this app bundle, right? If you want to update an existing app bundle, it's everything here. It's not covering this collection, but it's just a matter of creating these requests is also good for practicing. And okay, these are the ranges that are available as of now under the additional notes. As soon as we move to 2024 version of Revit, we are going to move the latest, earliest version of Revit will be to 2019. So This list will always have this number of engines available, and these are the names that you can use to refer for them. Next step, we need to publish an activity. So far, so good. Let me see if we have any question. No question. All right, now let's publish one activity. As said before, and it's also say once more right here, activity is the action that can be used in design automation. It is the whole orchestration of how many inputs we are going to have, how many outputs, which app bundle we are going to use, and so on. All right. All right. First step is the creation of the activity. The activity have always this specific body that we need to specify, and in this body we'll have everything that is required in order to run a job or run multiple jobs on design automation. As I said before, it is the orchestration of design automation job itself, right? So if we go on our task 4, this is the call that we're going to make to create a new activity. Let's replace this one, the one that comes by default, with the one that we have on our tutorial. Okay, as you can see right here, first of all, it has the ID. We can specify the ID for this activity itself. Since this activity is to delete walls of a Revit file, a good name is delete walls activity, because we can take a look at these activities in a list of activities available and get to know, oh, these activities is for that reason. We have also the command line in the activity itself. Command line is just like execution parameters when we are batch processing a file. So basically we have the engine path, the executable for Revit version that we are interested in this case. In this case, we are using the Revit core console.exe. We have the input parameter, in this case the Revit file, use it as input, and also we are specifying which app bundle we are going to use. This app bundle right here needs to be the same one that we have here, and also needs to be the same that we used when we created the new app bundle. Since we are following the tutorial, the name is the same, but it's always good to know what we are doing. In fact, this is a reference for this app bundle right here. As you can see, this is an array, meaning that an activity can have multiple app bundles. That's why we need to specify which one we are using in the command line. Inside the parameters of the activity, we have both the Revit file and the input file and the result file. In this case, the Revit file is referred as the input, as you can see right here. This is going to be the input. And we have in the activity the definition, if this input is a zipped file or not. If it is on demand. What is on demand? On demand is when we are going to obtain this in the middle of the execution of the work item. We can obtain multiple input files at the beginning of the execution of the design automation, or in the middle of the running, or at runtime. What's going to control that is this on demand right here. Since this says false, the first thing design automation is going to do is downloading these inputs that we specify. This is the verb. Since this is an input, the verb is always get. For outputs, the verb is put. We have a description and the local name, right? In this case, it is referred as the argument that we pass, and the result is specified on the activity itself. And then our app bundle is going to generate a file with this name right here. That bundle is going to generate the result at RBT, and the activity is saying that after the execution is done, it's going to look for a file with this name, and this is going to be the output. So this is going to grab this result file and upload it to wherever the user specified. Under this engine field, we need to specify the engine that we're going to use. I want to use 2022, and we also need to specify the nickname for our app, our APS app. As we said right here, our nickname is AECtech JPOM. So I need to replace this, and if I send the request, I can see that my activity was created. Are you able to hear the noise of my? Is there any noise that you are able to listen? Oh, I think they stopped it now. Sorry for that. They don't do it every day, but yeah, just like the day that I'm recording, they need to do this. Sorry for that. If they keep with that, I will ask them to do it a little bit later, the cleaning. All right, so now we have this activity available. We can use this activity, but we have also this activity specified as version 1. And just like we did for the app bundle, we need to create an alias for this version. That's what we are going to do in the next step. Create an alias for the activity itself. So if you go right here, we can specify an alias pointing to a specific version. This is version 1, but the activity ID is this one right here, delete walls activity. So I need to replace this activity right here. All right. So let me select a name. Which name can I use? AECtech activity. Okay. Now I create this alias. Okay, created, success. Now every time that I use the activity with this alias, it's going to point to version 1, which is this version right here. If I create another one, updating the activity, the next one will be version 2, and then I need to assign the alias to the new version, and I can keep controlling that through the assignment of alias. All right, from there, we have an additional note here on the command line. Oh, we added, this was a addition to the design automation itself. Previously it didn't have these codes. And now we can move to task 6, prepare the cloud storage. As I said before, our API, our design automation API, can take advantage of input designs available in the cloud in any storage. It doesn't really need to be available in an APS bucket itself. It can be available in any storage. You just need to provide a signed URL So in order that design automation can download the data and upload the resulting files. All right. This tutorial, if I'm not mistaken, it's going to create a bucket, upload the file to bucket, and generate the signed URL. We don't need to cover that. Actually, we can take advantage of the file that we uploaded inside our, actually, no, let's do it. Let's update. It will be better. So you have a way to update it. We already created a bucket, so we could use that one, but just for a matter of completing the training, let's create another one. So once more, when we create a bucket, we need to specify a unique, globally unique name. This name needs to be unique across the whole platform. So names like testing is not going to, test bucket are not going to be available for sure. So here we have the policy for this bucket. In this case, it's persistent. I keep forgetting the names. Persistent, it means that your file is going to be stored forever until you delete the bucket or the file itself. Temporary, it's going to read your file, it's going to store your file for 30 days, and transient for 24 hours. Okay, so let's change the name. Let me call it JPOM AECtech. Okay, let's see if this name is available. Great, it is available. Now I have our bucket with persistent policy, and now we need to upload our input file into OSS. Since until last year, the way to upload files to manage these translations on our platform were through signed URLs. You simply needed to generate a signed URL, and then you were able to upload and download files. As of now, we are doing this straight from AWS. We are granting you access to AWS S3. This is covered in this blog post right here. If I filter by Jaime, this one, right here. This blog is covering all of the changes that we have, and this is a new approach that we have. We have better performance, but we have more responsibility, and also a few APIs have changed. Since you are looking at that for the first time, you might not have to address this because you're already using the new methods. But if not, take a look at this blog. This is going to be deprecated by the end of this year, so it is always good to stay updated. All right, so first of all, we are going to generate a signed S3 upload URL. This is a single URL to upload our whole file. It's using this endpoint right here, OSS objects, this endpoint right here. Through this endpoint, you can specify with this access query string parameter if this URL is for uploading or downloading objects. All right, default value is read, and you also can specify to use the new method. You always need to specify use CDN equals true, And you also need to specify the minutes expiration. It tells us for how long this URL is going to be active. So if I generate a URL right now and say that it's going to be valid for 60 minutes, if I wait 2 hours to use it, it's not going to be available. This sample is making this URL available for 30 minutes. So as soon as I press push send, as soon as I send the request, I have 13 minutes to start uploading this file. As soon as I start, it can take as long as it needs to finish. But I have 13 minutes to start using this URL. Let's push send. Oh, I need to specify the object key. I have my bucket key here, but I haven't specified any object key. The object key is the name of the file that I'm going to upload. Let's call it, how can we call it? It is a Revit file, so let's call it Revit sample.rvt. All right, Revit sample.rvt. Now we can send the request. Oh, it started to right here. Now we can send the request, and I need to use this URL to upload the file and this one to complete our upload, right? Oh, sorry for that. This one is not using this endpoint. Sorry for that. That one is using another endpoint right here. That one, sorry for that, guys. That one is using this endpoint right here. Signed S3 upload. It's always also using the new method directly to S3, and through this endpoint, we are going to retrieve the URL to download our model and upload key. So we have an extra step here. We are going to upload the model to this URL, and after the upload is complete, we can then complete this upload. It's basically saying to our backend, I have uploaded all of the parts to the URLs provided. You can go and build the file and make it available in the bucket. So these are the two steps available. First of all, put it to the pre-signed URL. As this is fully automated, as soon as I send this request, it's going to grab this URL and send it to this variable right here. The only thing we need to do is to choose the file. In this case, I'm going to use this one right here, and I can put it. Okay, done, uploaded. Now I need to instruct our API to build the file based on the binary data that I transferred. So I need to use, for that, I need to use the upload key that I received. And once more, as this is automated, as soon as I send this request, this upload key value goes straight to this environment variable right here. So as soon as I click send, missing or invalid parameters. Okay. Let me try once more. Okay, now it's good. It didn't upload it. I don't know why. Now it's completed. Our file is available on our bucket. We don't have the endpoint here in this collection to view the files in our bucket, but we can take advantage of OSS Manager in order to view that, right? If we paste the credentials from our app, we'll be able to see all of the available buckets and objects. So if you go right here, under EOS. This is the one that we just created. And in here we have our Revit file, right? If I click here, for instance, it's going to start translating, and then we can view it. But since you don't need that for now, let's just consider it done. Uploaded, we completed the upload. Now we need to generate the temporary download for that input file. This one right here is going to be the input file for our design automation job. All right. So design automation is going to grab this input file, process the tasks that we specified, and then it's going to upload the results to where we specified. So for that, in order to be able to do that, we need to get the temporary download URL. Get the temporary download URL is done from using this endpoint right here. This endpoint right here. This is the one that I was referring to before, right? It has the use CDN equals true to use this new method. The access is going to be read so in order to make a signed URL to download, and write in order to make a signed URL to upload results. And you also can specify the minutes expiration and if this URL can be used only once or not. In this case here, we need to make a reference to that model. So here we have the bucket and the object. And as soon as we send the request, it's going to be set, send us the signed URL, right? Since this is automated, once more, it automatically going to update this to an environment variable. Now that we have the upload URL, we need to specify the upload, the download URL. We need to specify to generate the upload URL for our output file. This delete wall sample is going to generate a Revit file. If you go under here, under create new activities, this is the result it is going to generate, a result.rvt file. I can use any name. It doesn't need to be the same one, but yeah, since I'm not much creative, I can use as output file results.rvt. So now I can generate a temporary upload URL. As you can see here, we have access right. And now we have the available, and since we have an automation, that's also available on environment variable itself. With all of that, we can move to our work item. All right, let's go. We were here. Prepare cloud storage, temporary upload URL, already defined. Now we go under submit a work item. The work item needs a specific data on specific body, and the body of the work item is always compatible with the body from the activity. If in the activity I specify that I need one output and one input, in the work item I will have the link for one input file and the link for one output file. They always need to match each other, since the work item is one execution of a specific activity. So right here, I have a specific activity for a job that I did. I can replace that with the one from the tutorial. And right here, I need a signed URL. Since I'm not using a zipped file, I don't need this zipped field anymore. So the temporary signed URL is right here. signed download URL, and signed S3 upload URL, right? So I can pass that to our work item body. So signed S3 download URL, just to check. E20 704 E20 704 E20, and the upload seven oh five 92CB. 705 2CB. Okay. So we have both of our URLs available. Now we need to specify which activity we are going to use. And the activity is the pointer to activity contains the nickname to track our APS application, the name of the activity itself inside our APS app, the activity we're going to use, and the alias for the version that we're going to use. All right, so in this step, this task 4, we defined all of those. Here we have the activity. It is the same. Here we defined the alias, AECtech activity. And in the task 2, we specified the nickname of our application. Okay, now I can click send. I can send a request. Okay, parameter app bundles. There's something going on. It couldn't find the app bundles. Okay, let me check the activity. Oh, when I created the activity, I created with the wrong alias for the app bundle. I'm using here this test app bundle, test alias, but my app bundle doesn't have a test alias. My app bundle is using the AECtech alias. So there's a good opportunity to update the existing activity. So to update an activity, I can copy this activity field right here, paste it right here, and the main difference is that the ID should be always null. The ID is specified in the URL right here. So let me update this one. As soon as I update this activity, this is going to be used, and I forgot once more. This needs to be the ID. It created the version 2, but the version 2 is also wrong. So I need to use the proper alias for that bundle, and now I update this activity. Now the version 3 of this activity contains the correct app bundle specified. So I need to use this version 3. One way to do that is assigning existing alias to a specific version. In my case, I want to assign this alias to the version 3. And what is the alias for this activity that I'm using? I'm using the AECtech activity. So I'm going to pass this alias right here in the URL. And also I need to specify which activity I'm using. Okay, now this activity with this alias is pointing to version 3. And version 3 is pointing to this app bundle, AECtech. This AECtech is pointing to version 1 of my app bundle, the one that I uploaded and specified. I don't need to change this work item because AECtech activity alias is pointing to version 3. So it's already pointing to the one that I updated, all right? So I can just create, and as soon as you create, I send this work item to run for this upload, for this input file to generate that output file. I'm going to receive the ID of this work item. And this is the time that was enqueued. The first thing that happens with a work item is that it is enqueued, and after it's grabbed by the queue, the design automation sandbox is going to download the resulting file. As you can see right now, the download already started, and we have a success. Right here, we have the status of our work item. The time it started, the download started, and the time the uploaded ended, right? So this is the time that you get that you generate consumption of credit under your specific account since the beginning of download until the finish of the upload, right? The time enqueued is not counted for consumption. And every time we have a work item done, we finish a work item, we have a report URL. This URL contains all of the logs that are available from the execution of our job. By simply clicking this log, we can download this report. It downloaded on my other window, on my other monitor. If I go right here under downloads, right here, this is the 55 report 55. I can open with text editor, and in here we can see all of the details of our execution. All right, as you can see, this is a short one, but it shows the full context of what we need, what we did. We have the command line. We have also DAS Open Network. Open Network is a new feature I'll cover with you after we're done with this tutorial. We have also details on the activity that we specified, the rapid fire results, so on. And then we have the proper log of our execution. First thing that happens is that is our download phase. The download phase starts, then design automation is going to download the file, the resource, and in this case it's using the URL that we specified, and then it ended the download. So from this point, and download phase successfully. From this point, our sandbox can take advantage of the Revit file inside itself. So it can run the script against this file. So this is what it's going to do right here. Start preparing script and command line parameters, so on. And it's going to run. And after that, after it finish running the script and generating the result, it's going to start the uploading phase. The uploading phase is also going to use the URL that we specified right here to upload the resulting file to the storage that we defined. All right, everything is covered in this report. If we have a fail during this progress, we will be able to check it right here. And also, one good recommendation, a good practice, is to always console log on your app bundles. If I console log anything inside the execution of my bundle, it's going to appear right here in this report. So if I have enough logs, I can tell exactly where my script, my app bundle is failing, right? It's always good to have logs to know better what needs to be fixed or not. From this point, we can download the resulting file from Revit itself. But instead of downloading, we can use our app that we just created to view this actually. So let's go under here. And to view this on our application that we created in the first session, we simply need to change the bucket because we used a different bucket. So I can go here where we created the bucket. This is the name of the bucket that we created. So I can pass this one to this part. Until it finishes running. Do you have any question? Everyone understood? Are you able to run a design automation job? No? We'll see more of design automation, but as of now, is anyone able to run a design automation? At least understand the concept? No reaction. Come on, team. No? Nobody? All right, I'll share a few more samples with you then. Oh no, I don't mean running it right now. Understanding the concepts. How can it be used? I don't mean that you are no expert or able to run any job. It's just understand. We're just here to understand the concepts. This is what's more important. Thanks. All right, and as of now, with our sample, we are able to see both of our models. We uploaded both of them, but if you remember, this sample only translates the models that were uploaded by the sample itself. If we go right here, models controller, right here, where is it? Get translation status. Translate model. Let's find the reference. Translate model is only called when you upload a model from the sample itself. So when we want to retrieve the status, if they return non-assigned, in this case right here, the translator was not done, it's not going to translate the model itself. So we need a way to translate this model. We can do that from from Insomnia or through the buckets tool that we have right here. I'm going to do just for simplicity inside this bucket tool, and later on I'll share a few options for Insomnia. So let's go back here. Now we can expand it, and I'll select both of them. Translation started, and I'm selecting now this one. Let me check. Okay, I think they are translating. Now we can check the progress from our application. Good thing that in our application we have the document browser, all of the extensions that can be useful for debugging. Okay, the result is being translated. Let's check the input file. Also being translated. Let's wait for it to finish. Almost done. And okay, as soon as the translation is done, we can load our model. Okay, this is the input file. Nothing different in this one, and the main difference. This is good for just comparing with the result that we have. The goal of our job, our translation job, was to delete all of the walls. So if we go under our result RVT file, we should be able to see a model without walls. All right, so we have the same models, but in this case, without any element of the class wall. Same for all of the views that we have available. I know this is not useful at all, but it's just a matter of showing the concept of the app itself, of design automation for modifying designs itself. Right here, also without any wall at all. Okay. Okay, so that's mostly design automation. That's one application for design automation. We also have this tutorial right here. This one right here, modify your models. This one is quite simple actually. It is quite simple too. It's taking advantage of one web application where you can specify the parameters, and these parameters are going to be used to later on update a specific Revit file. And this way, this sample manages the activities, manages the app bundles, manages the creation of those and everything that you need to create an application and connect with design automation itself. Now, one good thing about one key thing about the design automation is that through design automation API, you can take advantage of the API of the product itself. You are not working with the translation of the SVF file, the SVF derivative itself. You are working with the actual model. So since we are working with the Revit design itself, not with the translation, we can take advantage of that to extract more data that we have available with only the translation. One example that I can share with you, I should have left this open. I asked before if you had any workflow for sustainability, for retrieving the materials of a specific design itself. I asked that because I was working with a partner, and this partner needed to take advantage of the materials of the model itself. If we go under the model through viewer or design automate or model derivative, they are the same. No, it's not the one I'm loading. Let me just load the correct model. Okay, if I go to this wall, for instance, we can take advantage of the properties, and these properties were generated by the derivative itself, by the translation. So if I go under the materials of this wall, I can see only one material. And this one material does not reflect the reality of the model itself, because this is one current limitation of model derivative. It generates for Revit files, for instance, it doesn't go through the details of each layer of compound layers elements. For instance, walls, floors, ceilings, all of those have compound layers. And if you want to take advantage of that, either for the thickness or for the materials that they are using, you can't rely entirely on model derivative. You need to go through design automation. And this is covered in one sample. Let me find it. Let me find the sample. This sample right here. This sample is basically take advantage of the selection of one element. As soon as you select it, one element, it's going to reach design automation, extract the compound layers information, and add this information in the property panel based on the selection. So for instance, you select this wall, you reach the information from design automation, from the compound wall layers in this wall, and present it in a list in this property panel tab, custom tab, right? But when we are working with materials, if you want to take advantage of all of the materials in the model, Revit API provides a simple way for that. And that's covered in one repo that I built a few months ago. Let me go through that with you. I just updated this one. It is right here. So this one, this repo, it contains the plugin for design automation, for Revit itself. It contains the app bundle already, and if you prefer, you can also download the snippet. I simplify it for this tutorial right now. But if you want to take it to know better what it is doing, you can always go under the class that we specify. Most of our samples, all of our samples, they use design automation. We provide the source code. So for instance, in this case right here, we are going through each of the elements on the model itself. And from the elements, we are using Revit API to get all of the material area and material volume. And we are adding that to a specific response from design automation. And this can be later on connected with external databases. From there, you can map a specific material from Revit with this material specific carbon footprint. And since you have the quantities, you can take advantage of the carbon footprint of your whole model itself, all right? So just for practice, let's take advantage of this bundle and run a job against this file right here, right? I already have it. Let me finish this. Let me finish this one. We don't need you anymore, Visual Studio. For now, only for now. So since I'm creating a new app bundle, I need to first of all register this app bundle. Let's go on right here and specify a new app bundle name. In this README, I have here ready the activity and the work item example. So in the activity, let's specify from there, let's grab the app bundle, a good name for our app bundle. Let me remove this activity. Let me call it Revit Materials Extractor. Okay, it works for Revit 2022 and extract materials from Revit. I can register this new app bundle. As soon as I do that, all of these variables are going to be available inside our environment variables. Let me share with you the link to this repo if you want to test it later. And from here, I can upload my app bundle to this registered one. I can upload the actual app bundle. I just need to replace the file with the app bundle that I just downloaded. Now I click send. Let's wait for it to finish. Okay, it is done. And now let's create an alias for that app bundle. We need to update the app bundle name, this one right here, and let's use the same alias, AECtech. Okay, sounds good. And after the app bundle, we need to create a new activity. And for the activity, we can take advantage of this sample right here. This sample don't rely on input parameters, on additional parameters. It only requests the input file. And here we are specifying the activity ID, the name for our activity. The engine we use is Revit 2022. The app bundle, we need to change that. And the description is good and everything is good. Okay, we are specifying that we have an input file that's required, true, is not zipped. The default is for zip is false. So we are specifying that we have a result file that's not zipped also. Now we need to update this app bundle alias with the full qualified name for the app bundle. So this is the bundle name. The nickname that I have is this one that we created. And the alias for the app bundle is AECtech. So let's use this alias right here. Okay. Oh yeah, we need to also specify this app bundle right here. They need to be compatible. This, and the app bundle that we registered, the ID. Now that we created the activity, we need to create the alias for this activity. So we just change the activity name right here. And I can keep the same name also for the same alias that we had before. AECtech activity. All right, now we have the activity ready and the app bundle. Next step, we need to provide the input and output URL. I don't need to upload another file. I can use the same one that I had before. As I said, most of our samples always use this Rabbit house built by Sam McAllister. So yeah, you see that a lot get used to that house. We just need to modify the output file itself. If you check the activity, this app bundle is going to generate a result, a JSON file as a result. It's not going to generate the modified Revit data. It's going to grab the materials, the quantities, and put everything together in a JSON file and update it. Oh, thank you very much, Molly. So we can go here, generate the download URL based on the same Revit sample file. And to the upload, we need to change the result name. Otherwise, it's going to generate a Revit file. So let's go here, copy this result.json. And okay, now we can specify generate the temporary upload URL. From there, I can create my work item based on the assigned download URL and the upload URL. There's just one difference right here, that this work item is always also using the onProgress and onComplete callback. So we can take the advantage of those by just copying this right here. And also for the result, is input file. The argument for the input is not Revit file, it's input file. If you compare with the activity, is input file and result. And right here we have Revit file and result. So we need to add input file right here. Last but not least, for output, let's use this post verb right here and add this header. Since we are talking about, we are generating a JSON file, all right? In this case, we are also going to use a callback. We are using two callbacks. One to tell us the progress of this execution, and the other to tell when a job is done, when the execution is complete. Since we are calling that from Insomnia itself, just for debugging, we have an amazing tool. It's called, amazing site is webhook.site. Oh no, it's webhook. This site provides us a URL that we can use to make post requests or to retrieve messages from any available resource, any available server. All right. So I can just copy this one. This is just for me, was generated for me. If you go to this site, you will receive a different one. And I can use that to retrieve my information from design automation engine, from design automation execution. So as soon as we have progress on my job, I'm going to be able to see the result here. And the same is valid for onComplete. So right now, Revit file is not matching. Oh, let me check. Oh, right here. Yeah. Let me check. That's something going on. Required parameter. Revit file. Created the activity. Let me go there here. Okay, input file. Oh, I'm using the previous activity ID. I forgot to change it. So if I want to use this activity, I need to specify this activity ID, the alias is the same, and the nickname is the same, and the alias for the activity is also the same. AECtech activity. So now I should be able to run my job. And it is enqueued. And since I'm using webhooks.site to receive my webhooks, I don't need to keep calling for the status anymore. As soon as this job is done, I receive messages right here. This one was for the on progress. As soon as our job is retrieved from the queue, it's going to return a message from our on progress callback. And the next message should be in 20 seconds, or if it's faster when the job is done executing. Okay, it got failed to upload for some reason. Let me check the work item. This is the report for this activity that we just executed. Let's check what's going on. Okay, started downloaded and it downloaded successfully. Okay, and failed to upload. 404 not found. Okay, the signed resource were not found. Let me try once more. Upload URL, output file, results.json in our bucket. So this is B6, starts with EE97, B6. B6, 404 not found. Okay, let's try once more. Let me clear this one. Okay, it started. We have the progress right here. If I want to load more, let me try a different thing then. Let me try to add put here and remove this. Maybe it's the verb that's not acceptable. And I need to fix that. Let me generate a new download URL, new upload URL. Okay, it was acquired from the queue. And that's a success. All right, so yeah, I remember it working, not sure, but always use put for the result. And now we can query this for retrieving the report URL. Let me delete this once. It's not downloading it. Okay, I'll download it. And if you check the new report, we can see all of the phases available. The downloading phase ended, the execution, and then the uploading phase successfully, and everything available. Now we can take advantage of our Forge Bucket tools sample in order to download the resulting JSON file. So we need to specify once more, the client ID, the client secret, login, and then if you go under here, we have our result JSON. We can download this file, and if we open it, we can check all of our results, right? I hope I haven't caused you headaches by opening this, but we can take advantage of JSON formatter. And that should be way better, right? So here we simply went through each of the elements and retrieved the material quantity and the material area quantity, volume quantity, the name of the material, the category of the element where the material lies, and the external ID if we need to map with the viewer or anything else, right? With that, we can connect this material with external databases and use, for instance, to query for the embodied carbon of each of these elements. All right. These units here are the Revit internal units. In this case, if I'm not mistaken, it's square feet for areas, for instance. So Revit has methods Revit API has methods for conversion between multiple units. Feel free to take advantage of those. This is just a sample to show one information that you can't query straight from model derivative itself. All right. I think it was enough content. Let me just share with you one sample that I've been working on. It will be available soon in the it will be available soon in a blog post. Oh, not this one. This one right here. Let me grab the link. Just a few seconds. The idea here is to go from viewer to design automation itself. Jaime, if I'm not mistaken, Jaime is going to share one with you guys on Thursday in the on-site event. But the one he's going to share is from scratch. But this one is when you already have a 2D view inside Revit itself and want to modify based on the elements that you specify on the viewer. The workflow that we can use, that this shows, is when we have, for instance, one Revit design, just like this one. I have a sheet view, so I can select, draw a line, for instance, and from this line, I can grab these points and submit a work item to design automation. From there, design automation is going to grab all of these points, draw model curve in the Revit model itself, generate a result file based on this design, upload this result to viewer, and then translate. So we should be able to see both of the cases, the Revit design without the markup that we did, and the resulting with the line that we just drawn. The main concept here is that the main difference here is that since we are talking about the translation and the original model, they have different coordinate systems. You get what I'm saying? The coordinate system from Revit is one. It has the base project point, the project point, the georeferenced point position on the project itself. And when you move a model to viewer, it's going to grab the bounding box, comprehending the whole geometries of the viewer itself. And from there, it's going to position the origin of viewer in the middle of this bounding box. So the coordinate system is slightly different. And viewer API, the methods in viewer library has methods so that you can take advantage in order to go from viewer coordinate system into Revit internal coordinate system. That's what this sample is doing to draw these lines in the proper position. After the execution of design automation, it just uploaded this design to this bucket right here. And right now, this is uploaded. That it got uploaded, we need to translate it. So this is what the sample is doing right now. The model is being translated, and as soon as the translation is done, we'll be able to view the result. All right, 23%. This is just to show what can be done using all of the services connected, the APIs connected. You could, for instance, take advantage of these lines to draw walls. It's also possible. So right now, you can see the model curve added. And if I go to my sheet plan, I can see the line that I just drawn. All right. Okay. This is not public it's public on the repo, but as soon as I have the blog, you should be able to have more details. It's always good to keep track of the most recent blog post. Every new API, new service, new method that we launch, we are going to blog about it. Every new feature that we launch, we have on our platform, we're going to blog about it. And also, it's always good to keep in mind of our events. Just like this one, that we are participating, we have our own accelerators and so on. So feel free to join us in coffee breaks and everything with your questions and workflows. We are here to hear about that. So with that, that's not everything on design automation. You have a lot to go through, but I think I said enough. We covered viewer, model derivative, data management, and now design automation for Revit. So if you have further questions, please ask. If you have any workflow, anything, I'm here to address your questions. You can also reach from Slack, but from the content of the class today, this is what I wanted to cover with you, right? Is there anything else you want to address? Any other content? Hey team, are you there? All good? Can you share the slides you presented? Yes, sure. I can share it. I have a folder and I can send to that. Let me just reach David. And yeah, I can do that. How does credit works for design automation? If we go under pricing, design automation, you have a charge for the processing hour based on the hours that your task needs to execute. As you could see on the jobs that we performed, we are talking about few seconds, right? It's from this date right here. So this one right here until upload and this one right here. So 40 seconds. So for 1 hour of process, you have 2 cloud credits of cost. All right. So this is for 1 hour. We had 40 seconds. So it takes a lot to consume 2 cloud credits, and you can take the way to know how much it's going to cost your app bundle. We can really tell for sure. The best way to know how much it's going to cost the execution of a job is you developing your app bundle and run it on multiple designs, large designs, small designs, and from there you can take advantage. You can generate a benchmark. You can have your own benchmark to know, oh, this task is going to cost these credits, this amount of credits. This other task is going to cost this other amount. The best way to know that is by testing your script against multiple files. That said, we also have a calculator. If we go under, Forge-calculator, you should be able to find a calculator. And in here, for if you need to create or modify models, you select the Revit engine, for instance. You can specify the model size, the complexity of the script, and the frequency of execution. We are going to provide you an estimation just to move away from the zero, just to have an idea, a basic idea of how much it's going to cost. And then you simply add it here, and you're going to have an idea. Oh, with this configuration, I'm going to consume 0.4 cloud credits each month. Offline version of the model derivative API. What do you mean by that? Offline version of, you want to translate the models without going through model derivative? What's your idea here? Oh, you want to generate the SVF outside of model derivative. generate the SCF for viewer. Oh, got it. No, we don't have that. I guess that I know that for some formats, you can go through design automation to generate that. But model derivative viewer itself, if you want to render designs on viewer itself, viewer runs natively a few specific formats. Let me share some content, just a few seconds. Let me just find the blog. Let me just grab the blog for you. First one is this one right here. Viewer has support natively for DWF and PDF. So what I mean with that is that if you have a DWF or PDF, you can load them without going through a translation. We have an environment, specific environment called local. You can use this local environment and load these DWF files or PDF files from your repository, all right? Without the need of uploading to Bucket and generating the translation. We also have support for GLTF. If you have a GLTF file, you can load it on viewer using the Autodesk.gltf extension, right? Without the need of translation. These are the formats that you can load with viewer without the need of a translation. Other than that, you need to generate the SVF or SVF2. You're welcome. Any other question? Okay, so I hope you found it useful and keep learning more about design automation and the services that I shared. Thank you for your time. Thank you very much for the time with me today. It was really fun. And I'll be available in the workspace. If you have any questions, just send me a message and I'll do my best to address those. All right? Thank you very much, guys. Have a nice day.